South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history, and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare, and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Assalamu alaikum wa rahmatullahi wa barakatuh, and a hearty good morning. We're coming to you live from the Glendale Secondary School in Rocklands in Mitchells Plain. Good morning to all the learners here. Good morning to Mr. Kota. Good morning to Khalid. The learners, they tired from yesterday. Yesterday, our national team took a bit of a hiding from the All Blacks, so everybody's a bit somber this morning. But nevertheless, good morning, learners. That's not good enough. That's not enough energy to get you through 6 hours of mathematics. Let's try that again. Good morning, learners. That's a bit better. Also to the birthday boy, yesterday Mr. Kota reached half a century, turning 50 years old here in the beautiful Cape Town. And we wished him a happy birthday. Mr. Kota, once again, a very happy birthday. And it's also a nice a word of encouragement to you is that you're giving of yourself to learners that's going to end up in the engineering field, the tech field, the medical field. And these are our future doctors and engineers and scientists and computer programmers that we have in the room with us this morning. Awqaf South Africa is the country's national endowment fund. It is a fund that literally collects funds, makes sure that money makes other money so that we can sustain programs such as these, and this being the mathematics workshop for grade 12. The second last round of grade 12 workshops for the year. With me this morning, I have Khalid. Khalid is going to be co-hosting with Mr. Kota. Khalid, over to you.
Thank you very much to Summit. Let's give him a round of applause, please. We are live from Glendale Secondary School in Rocklands, Mitchells Plain. If you're not here, please do make your way. Even if you're coming back from church, we will still be here up until 3 o'clock this afternoon. Next week, we are coming to you live from Amanskral in Pretoria, in Gauteng, with the grade 11 Pure Maths workshop for Awqaf SA. Mr. Kota will be there. Do make sure that if you can't be in Pretoria next week, at least you can join us online for those particular sessions. Mr. Kota, I don't want to take long. What is it that we need for this morning? And I believe that we're doing paper 2.
Yes. Good morning. How are you, learners? Are you ready for today? Another bumper session, guys. Just want to say thank you to Samit for the beautiful introduction, as well as Khalid here, our team, and to say thank you to the Department of Education and your schools, and mainly to you guys for sacrificing your weekend, because I think you understand the importance of this program. Today, you need your scientific calculators, you need your books, and you need all your snacks. Yesterday, I almost choked to death on the peanuts, so today, no peanuts for today. Right. So, another exciting day of mathematics, guys. I want to wrap up from what we did yesterday. That's where we stopped. We stopped with the calculus. I just want to wrap up on that optimization. We did calculus, we did finance, and we did the whole of functions yesterday, right? What I want to do, I want to go into paper 2, and then towards the end of the day, we'll go back to paper 1 and finish up the sequences and series. So let's push as much as we can in the short time that we have. I know you might think 6 hours is a lot, but before you know it, today is over. We have so much of work to cover. Okay, guys, to our online cohort, welcome. Hit us up from where you are tuning in from across South Africa, Mitchell's Plain. We beaming here from the mother city, beautiful Cape Town. Woke up this morning to a foggy morning, couldn't even see the road, couldn't even see Table Mountain, and Cape of Storms. Welcome to everybody. How's our onliners? Have they all come in? Are they in? Are they ready to dollar math? Let's get the whiteboard up there, Summit, and let's get the show on the road. This is where we ended up yesterday. Let's check.
We have a good morning message from Ariane Kheng Secondary School, I believe, that is in Joburg. And there are many students that have joined us as well from Ladysmith as well as Mpumalanga.
Thank you, Khalid. We had one of the comments that came in yesterday. Mr. Kota got choked because he didn't have his oxygen break.
He didn't take your oxygen break, so please to take.
He didn't take his oxygen break. We need the oxygen. Let's go, because now we're talking like Donald Trump. Let's go. Okay, guys, let's go. Right, we stopped here yesterday. I'm going to die. There's it. Old age is kicking in from day one. Let's go. All right. So we ended off yesterday with A is equal to 2, B is equal to 6. We didn't do this find a straight line distance of PB. I gave you guys homework. I bet you nobody did it. I know you so well. I know you didn't do it. You didn't even open up your books. I hope you guys had a chance to have a look at what we've done yesterday. Did you? No. Some of you are babalas. Oh, I saw the pup suck there outside. I'm like, anyway. All right. How do we find the straight line distance PB? There we go. That straight line distance PB. How do we find that straight? Oh, it don't look like a straight line there, bruh. Right, there we go. Find the straight line distance PB. Right, let's go. How do we find PB? We know we got B's coordinates. They want the straight line distance PB. P's x value is 0. And what's its y value? What's its y value? Right, now we don't know. Look here, what we have to do, we got h of x. We got h of x is equal to, we got a, so that's 2x cubed plus 6x squared. So now we're going to go h of minus 1. We're going to go, remember we got m's x value. We don't have m's y value, because m's y value and p's y value is exactly the same. That is why I'm now going to take h of minus 1. That's going to be 2 into minus 1 cubed plus 6 into minus 1 squared. So h of minus 1 to get our y value is going to equal to, that will give me minus 2 plus 6. H of minus 1 is equal to 4. So m's coordinates is minus 1 and 4. So p's coordinates will be 0 and 4. Because it's a straight line. Remember, it's parallel to your x-axis. So now we have the y value here of p. P is 0 and 4. Guys, are you with me? Grade 12, are you awake? Right. They want the straight line distance PB. Therefore, PB is equal to the distance formula, the square root, the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So PB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. PB's distance is equal to 36,1. 36,1, whoa, 36,1 kilometers. There we go. That's your maximum length of PB. Please know your distance for all your formulas by heart. Do not even look at your formula sheet. Your formula sheet is toilet paper. Wipe your backsides with it. Online, how are we doing there? Shout out to Tanya there. I'm trying to mango fish in the house. So this is where we're wrapping up yesterday. This was yesterday's work. Now there's one more concept in optimization. A few pointers for you before we wrap up the calculus, and then we're going to go straight into analytics. Let's go into paper 2. Let's get that paper 2 going. So remember your algebra from yesterday, your full 25, 26 to 30 marks there, guaranteed. Your full 40 marks or 35 marks, let's say 40 for functions, guaranteed. So 40 and 30 is 70. Another 40 marks for calculus, 110, guaranteed. Finance, another 20 marks, 130 out of 150, guaranteed. We are not aiming to pass. Destination, distinction. I told you yesterday we got learners floating in their 90s. They're playing in their 90s. You always get 20% less than what you aim for. You aim for 120%, meaning you are more than prepared, you'll get your 100. You aim for 100, you'll get 80. Some of you are only aiming for 30 to pass. You do the math. Okay. Remember, the aim of yesterday and today is to get you moving, to get your wheels turning. This is the race. It's a Formula 1 race. You need to be Hamilton, you need to be Verstappen in the car, in this Formula 1 car. And let me tell you, the formula, the engine to this Formula 1 car in mathematics is algebra. Get your algebra. What is mathematics? It's a scenario, it's a formula, it's substituting into the formula, knowing the controls, then the engine of algebra is the wheels. Algebra will take you to your final. After the formula is not maths, it's algebra. It's only algebra that takes you to your final answer. So you must just know where to plug and play. You need to know where to put your controls in. So you can't be sitting with the formula sheet in the exam. Imagine you're going to drive a Formula 1 car on race day. And now you're sitting with a piece of paper in front of you to say, okay, press start. Okay, put the clutch in. Okay, and sometimes you're not going to have communication. Remember, you're sitting in that car, you're sitting alone. You troubleshoot, something goes wrong in that car. You need to know what to do, how to fix. Right. Back here to math. Let's start. Total surface area. Total surface area for a closed top and bottom. For those, I know many of you have been here before, some of you haven't been here. Let me give you the formula again. For closed top and bottom, for a closed top and bottom of a shape, is what? Who remembers this formula I gave you last time? 2 times area of base. 2, because we got 2 bases, top and bottom. These are your bases. 2 times area of base plus perimeter of base times your height. So just remember 2AB, 2 times area of base plus perimeter of base times height. 2AB plus PBH. Don't forget this. Don't forget this. So if I gave you, I'm just giving you an example, if I gave you a cylinder or drinking and I told you to calculate the total surface area of this, the bottom is closed, the top is open, it's a cylinder, and let's say that is 10, and let's say that is 50. Right. Calculate, let's do this one quickly. Let's calculate the total surface area of that shape. What is the total surface area of the shape? There's only one base. So in this case, total surface area will be 1 times area of base. I'm doing this question here. 1 times area of base plus perimeter of base times height. So area of base, area of a cylinder, pi r squared plus perimeter of base, the circumference, 2 pi r times your height. So that, I'm just going to use pi as 3,14 for now. You can use pi on your calculator or 22 over 7, up to you. R squared is 10 squared plus 2 times 3,14, that's pi times r times height. Total surface area of the shape. No, why am I putting the square outside? That is haram. Right, let's go. 3,14 times 10 squared equals plus, open brackets, 2 times 3,14 times 10 times 50. Boom, close, equals. Your answer, 3,454. Let's say this is centimeters, so it's centimeter. It's area, so it's centimeters squared. That's your total surface area of that shape. Please remember this formula. P 2AB plus PBH. 2 times area of base plus perimeter of base times height. Another very important concept that I need to, which we did yesterday. I'm just wrapping up with yesterday's work. Khalid, how's our onliners doing? Talk to us, Khalid.
Having a go at each other here, Mr. Kota. It's them who must talk to us, actually.
Yes. How are they doing? How are you guys doing, onliners? Are we all okay?
I see Mango Fish is here. Laik is here.
That's it. Who else? And what's there?
Keisha is also here.
Nice, Kishan.
There's a shout out to Pinelands High School. Ibtisam Samsudin as well. Joseph is here as well.
We had learners here from Darul Arqam as well here yesterday. Welcome, welcome, welcome. Thank you all for joining this program. Okay, here we go. Now, what I wanted to show you from yesterday as well. Remember, we said velocity. Whenever they talk about velocity, is speed. And whenever we talk about speed, it's first derivative. Make a note of this. And then what do we have? Acceleration. And acceleration is second derivative. Acceleration is ms to the minus 2. Meters per second to the minus 2. This is meters per second to the minus 1. Remember, we minus 1 from the power. That's why it's first derivative. So acceleration is also concavity. It's the same thing. It's also called point of inflection. I'm just wrapping up. I'm doing some touch points. What do we also know? Whenever they talk about minimum or maximum, derivative must equal to 0. Always. Because there's 0 acceleration and 0 speed. It's dead. It's a turning point. Minimum or maximum is your turning point. Nothing happens there. No movement. Okay? Another very important concept, there's 2 more concepts I want to wrap up with that I need you to remember for calculus. Right, now watch this. I know we've done this in the last workshop. We'll continuously do this all the time because it's a very important concept. When they give you a graph, any graph, right? I'm just giving you an example. So let's say they give you a graph, right? Then they give you a Cartesian plane. Let's say they give you a graph that goes like this. And this is graph F, and they give you a point on F, and they say that is point B. Point B is 10 and 20, and then, no, they don't give you that. They just told you, they just call that point B, and then they call this point A, and they tell you A's coordinates is 0 and 12. And they tell you that this graph f of x is equal to, let's say, 2x squared plus 4. Right. Now they'll ask you to find the maximum distance of AB. Now, whenever they don't give you a coordinate on a graph, please, I want you to remember this. I'm writing this here on the side. Whenever they don't give you a coordinate on a graph, you're looking for it, you don't have it, and it's usually in calculus, right? So in calculus, whenever, so write this down, make a note this, whenever they don't give you a coordinate, or if you need to find that coordinate, then you call that coordinate x and f of x, always. So they don't give you this point, so you call it x, and its y value is f of x. Its y value is f of x. So what's its y value? 2x squared plus 4. The equation of the graph is its y value. I'm going to write it here. The equation of the graph, the equation of the function is the y value. Obviously, because no matter what x is, you're going to plug it into here, into the equation, and you're going to get its correct y. So now if they ask you to find the maximum length of AB, let's do this one together. Let's say the question says find AB. The question says find the maximum length of AB. And let's call that 7 marks. So let's all do this one together. So anytime on a graph, if you need a pair of coordinates that lies on the graph, that coordinate is x and f of x. Right, so now we're going to say AB squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. I hope this one works. I made it up, but I'm sure it should. x2 minus x1 all squared plus y2 minus y1. We'll call this one x2, y2. We'll call that one x1, y1, all squared. So AB squared is equal to x squared plus 2x squared minus 8, all squared. AB squared is equal to x squared plus, this would be 4x4 minus 16 minus 32, x squared plus 64. AB squared is equal to 4x4. 1x squared minus 32 is minus 31x squared plus 64. That's AB squared. Now we need to find x for maximum distance. And after we find x, we put it back into the original, and then we find the maximum distance. But it's in terms of squared. So in our final answer, we'll just find the square root. I think you know where we're going with this. Right, now let's go and find, what are we finding now, guys? X, am I right? So we're going to say DAB squared over DX is equal to 4 times 4, 16x cubed, minus 2 times 31 is 62x. For minimum maximum is equal to 0. Let's take out x. What am I left with? 16x squared minus 62 equals 0. X equals 0, or 16x squared minus 62 equals 0. 16x squared equals 62. X squared equals 62 over 16. 62 divided by 16, boom. We get 3,875. So x is equal to plus or minus the square root of 3,875. Boom. What do we get? 1,96, 1,97, 1,97. Now let's put in positive. So now we're going to put this 1,97 into AB squared. So now put here 1,97. So 4 open brackets, 1,97 close brackets to the power of 4. Remember, I am putting this 1,97 into here, into AB square. I'm putting it into this equation for every x. Right. So AB squared will equal to 1,97 to the power 4. Let's go to the side, minus 31 into 1,97 close brackets to the power 2 plus 64. Boom. What do I get? 3,94. So AB, your final answer is the square root of 3,94. AB is equal to the square root of 3,94. Boom. Oh, I get 1,99, almost 2, 1,98. Let's call it 2, approximately 2. Learn this concept. Right, Khalid, all our registers in order. Our learners are all on fire. They're all having their coffees and their donuts and their breakfast, and they're eating calculus for breakfast. Okay. One more concept in in calculus. One more. This is my breakfast. Salt and vinegar popcorn. Let's go. Can I raise? So why did I teach you this concept? I told you because they didn't give us this coordinate on the top. The minute they don't give you a coordinate on the top, guys, we call that point any point x. Its y value is f of x. And f of x will usually be given 2x squared plus 4, x and y. Does it make sense? Grade 12s, are we all okay? Are we on the same page? Good. Let's go. I'm erasing. Here we go. One more concept. Very important concept. Just before we wrap up. I know you've seen this before. Check this one. If you've worked through past papers, you would have seen this one. All right. They give you a parabola in calculus. And they give you that as -1. They give you that as 5. Right. They tell you this is g dash x. So they tell you sketched is the derivative. Sketched is the derivative of g. That's given to you. That's your arrows, that's your y-axis, that's your x-axis. Question, that's given. Question number 1. Now here's the questions on this. They love this. They love this question. How many of you have seen this before in past papers? No one. You haven't even started with past papers. Ya salam. Nice. Don't worry, you're doing well, man. Kudos to you. Brownie points. You're the shit. If you haven't mastered at least 12 to 15 past papers already, die kak gaan spat. The shit is going to fly. It's going to hit the fan in the exam. It's going to be one messy room. Julle gaan kak. I'm telling you now, 12 to 15 paper 1s and paper 2s, you should have memorized. Don't take my word for it. Well, who am I? Don't listen to me. Why you need to listen to me? Do what your own brain tells you. We'll see. We'll see. Let's go. Right, the first question. Right, I want the x coordinates of the stationary points of G. Number 2, I want the x coordinate of the point of inflection of G, for which value or values of x is G increasing, concave down. Question number 4. Find the derivative. Right, mark allocations. 2 marks. 2 marks. 2 marks. 2 marks. 3 marks. 2, 4, 6, 8, and 3. Let's make it 2 marks again. Total marks 10. Onliners, how are we doing there? I think there's a shout out there.
Yeah. The shout out is from Yakin Jacobs, saying shout out to Ezra Manu. Is it Manu?
It's all happening here in Mitchell's Plain in this hall, brah. That shout out is coming here.
She's my friend and she's working hard there at Awqaf Glendale. So I believe Ezra is here. Ezra? Where's Ezra? Smile for the camera. Ezra, who is Yakin to you? That's the next question.
Is that Mr. Lover? I'm joking. I'm teasing. Right, let's go. The x-coordinate of the stationary point. So that, what is stationary point? Turning point. Now, listen, this is your derivative graph. We know that the derivative of a cube is a parabola. So they sketch the parabola. These x-intercepts of the derivative are the two x values of your turning points of G. So you're going to say minus 1 ny, and you're going to say 5 ny. Those are the two. Now, what I want you to do in the exam, watch here. Watch here. Put your pens down. In the exam, I want you to draw a rough graph. It's a positive parabola. It's a positive derivative. Sometimes they can give you a negative derivative. Be careful. So just draw a rough cubic graph. And we know that this point here is minus 1. And we know that point there is 5. Do that. It will give you a picture of what your original graph G looks like. This is G dash. Your original looks like this. Are you with me, guys? Right. X-coordinate of the point of inflection. So it's the halfway mark between here. So this is 1 and that is 5. 1 plus 5 is? 1 plus 5 is how much? 6. And the halfway mark is divide by 2. 6 divided by 2 is how much? 3. So it's 3 units this way. It's 3 units that way plus 3. Or it's 3 units that way minus 3. 3 units. So it's the half. Remember, the turning point of your turning point is your second derivative. Second derivative is the turning point of your turning point. First derivative is your turning point, am I right? So second derivative is what? The turning point of your turning point. Make sense? The derivative of your derivative. Second derivative. The turning point of your turning point. So here's your turning point. That's your turning point graph. The turning point of your turning point is called your second derivative. Oh, didn't know that? So your turning point of your turning point, the derivative of your derivative is your second derivative. Yoo-hoo. Right. So 3 units this way. So what's it going to be? 5 minus 3 is how much? 2 ny. So they want the x coordinate there. 2 ny. Don't ever forget that. Second derivative is turning point of turning point. The minimum value of your turning point or maximum value of your turning point is your second derivative. Right. For which value or values of x is G increasing, we look at original graph. Concave down, you can find it on your original because that point there is 2. There's your point of inflection. Now, there's 2 ways of looking at, all right, let's look at increasing. Increasing, we're looking at our original graph. So here we go. We know it's increasing there, and we know it's increasing there. So it's for all your, I'm answering increasing. It's for your x values less than minus 1 or your x values greater than 5. That's where your graph is increasing. It's decreasing between there and there. That's decreasing. That's increasing. That's increasing. Where is it concave down? Now, concave down is either to the left of the derivative graph or to the left. Here, in this graph here, here's concave down, the sad face here. So you look at your point of inflection. So it's x less than 2. X less than 2. Concave down. Or you can look at it here, on this graph here, x less than 2. That's concave down. This is concave up. From here, from 2 going up, concave up. From 2 going that way, concave down. On your graph, from here going there is concave down. And from 2 going up is concave up. But you have to look at your point of inflection. Turning points. Turning points will tell you increasing or decreasing. Point of inflection will tell you point of concavity. Agreed? Find the derivative. So they want the equation of that. That's a functions question. Very easy. Let's find the derivative. How would we do the derivative? All we do, we say y equals x minus x1 into x minus x2. So g dash x is equal to x plus 1 into x minus 5. G dash x is equal to x squared plus 1 minus 5 is minus 4x minus 5. That's your derivative. That's g dash x, the equation of your function. And that brings us to the end of calculus. So this is a very important concept. So I thought I don't want to leave it out. Just now you guys are going to see it. I'm telling you, you're going to see something very, very, very similar. Now, you know how else they may rephrase this question. They may say that g dash x is equal to ax squared plus bx plus c. Find a, b, c. So all you do now, ax squared plus bx plus c, that's your derivative. So a equals 1, b equals minus 4, and c equals minus 5. Don't get a shock. Just remember what I'm showing you. You'll be all right. You'll be sharp. All right. Right, let's go into analytics and circle analytics. Let that take us right through until our first break. Let's go into analytics and circle analytics. So quickly, what do we need to know before we go into let's go into some background information. Let's go into some background information quickly. What do we need to know about, look, definitely 100% in analytics, you're getting 2 questions, right? You're getting one grade 11, one grade 12, 40 marks. 20, 40 marks. Maybe 35. 35 to 40 marks. 2 questions. Remember your angle of inclination from grade 11. Parallel lines, you got to know equations of straight line, midpoint formula, equation, and then circle, grade 12. Let's go into grade 12. We know x minus x1 all squared plus y minus y1 all squared is equal to r squared. The equation of a circle whose center is not at the origin. We need to know equations of tangents to a circle. And if they give you a new circle, so let's go. If they give you a new circle and they say, will the two circles intersect? When they give you two circles, and if they ask you, will the two intersect at two distinct points? Have no points of intersection? Touch each other externally at one point or be tangential? Intersect at two distinct points, meaning like this, two circles cut like that, have no points of intersection, looks like that. Tangential or touch externally at one point, looks like that. For two distinct points, if the distance between centers of the circle is greater than the sum of your radii, then you'll have no points. So this one, two distinct points will be less. Less than the sum of your radii. Then they will have two distinct points. If the distance between the centers of the circle is greater than the sum of your radii, then they'll have no points of intersection. If the distance between centers is equal to the sum of your radii, then they will just touch once. Take this down. Let's start with the model. I'm going to give you one model. Let's work it out. Let's crack it back to front, and that will take us till our first break. We come back from first break. We will then go into trigs. Now, do you know how messed up is my brain? Before I went to sleep last night, I'm like falling off to sleep. And a trig problem came to my mind. And I said, let me show, I need to show them something tomorrow. What's wrong with me? Ooh. When you are wired with numbers, you are dreaming numbers. And then you get excited. Then I couldn't sleep. I said, hey, I must show them this. Doesn't maths keep you awake at night? I know for some of you it's a nightmare because you sweat. Hey, Right, so you all took this down, right? Just for fun. Before I forget it. Now I'm talking to you. Maybe later I'll forget it. I see the picture in my mind. I got the picture. Simplify. I just made this one up. Simplify to a single trig ratio. This has got nothing to do with analytics, please. This is just something that popped up in my head. Simplify to a single trig ratio. Oh, Lord, I forgot. Sin x cos x. For 3 marks. That's the question. Quickly, how's our onliners doing? This is just for fun. This is what we do for fun. Some people go fishing. Some people go skydiving. We create maths. No, we. We are together. Ubuntu. Simunye, we are together. You are all psychos like me. Don't worry. It's only a psycho who can spend a whole weekend with another psycho.
Even mango fish.
No,
is
no,
crying.
and I got more psychos online who spent last weekend all-nighter. They started 7 at night till 2 o'clock in the morning, Friday night and Saturday night last week. They are back again this week. Who's more crazy, me or them? Exactly. Exactly. Anybody? Yeah, he's crying. He was there with me last week. He's again this week. Now look, your double angle for sine, isn't it sine 2x? Isn't your double angle 2 sine x cos x, which is equal to sine 2x, yes or no? So if I attach a 2 here in the front, 2 sine x cos x, then I must multiply the 2 by a half. Because half times 2 gives me 1. We're not changing it, we're just introducing it. Make you pop up. So now this is half, because half times 2 will give me 1. And then 2 sine x cos x is your double angle for sine. And that's your answer. Half sine 2x. Who got that one right? Any of our onliners got that one right? No bird. Are you lying? Wakhlanya. Nskawapa. You are talking shit. Tell them, sir. Tell them. Show them. Mango fish, did you get that one right? Yo, Zaza. They are like chips. Okay. People, right. Here we go, here we go, here we go. It's just a concept I want you to remember. Right. But we'll talk more about trigonometry when we get there. I got some hot tips for you. Some fresh ones. When you can't get an answer, you just make that expression equal to x. Then you square both sides. And then you are dalai. Then you are moving. Sometimes when you are stuck, when your car is stuck, you are driving 300 in a Formula 1 car and you get a tire blowout and now the car is on the track, stuck like your brain in the exam and you don't know what to do. You just either use a grade 11 identity, that's one tool to use, that is a power pack, and another power pack to use is you equate it to x and solve. You'll see when we get to trigonometry. Show you some tricks today in case you get stuck on the track while taking a bend in Monaco at 300 kilometers per hour so you don't crash. Right, let's go. All right, so let's take this one down. So we finished with that. All right, let's do one. Can we make up one, right? Let's see if I can ask you every humanly possible question on one diagram. So let's create a diagram. Let's create something. We are creators of mathematics. Right, let's go. That's point P, the center of the circle. Let's say P is X and Y, right? Let's say x squared plus y squared minus 10x divided by 2 plus 4y Now you see what we want to do. Plus d equals 0. I give you another point on the graph and I call that point B. We'll give you a tangent to the graph there. And B's coordinates minus 10x, 10 divided by 2 is 5x minus 5, so that's plus 5, is 2 and 6. Right, question number 1. Question number 1. Find the coordinates of P, the center of the circle. Question number 2. The value of D. Question number 3. I want the equation of the tangent RBT. Find the equation of the tangent RBT. I'm going to give you another line here. RBT. Let's call this point L. KRN. There's angle theta. Great.
Nenzane kitchen.
Find angle theta if the gradient of Ln is equal to is equal to 0, is equal to a half. Right, go for it. Take this down. You can start with it already. You can start with it already. That's your x-axis. That's your y-axis. And let's go with one last question. Another circle with center 10 and minus 4 and radius of 6 is drawn. Will the two circles intersect at two? Will the circles intersect at two distinct points, or have two distinct points of intersection? Right, let's go. There we go, guys. We've made it up. There's a complete component for you. Fine, right, have you taken it down? You started with it already? How's our timing there? How's our comments? Onliners, are you still on fire? Right, now the first thing you do, the minute they give you something in this form, rearrange it in its proper form. So we're going to say x squared minus 10x plus y squared plus 4y equals minus d. Yes or no? In fact, what we should have done from the start is just made this, we could have made this a minus. Make that a minus d. Then it will come on the side as plus d. Make this minus d. Then it will come on the side as plus d. Right. Now we complete the square. The shortcut of completing the square. If you attended our workshops before, you saw the shortcut. Divide by 2, divide by 2. So that's x minus 10 divided by 2 is 5 all squared plus y plus 4 divided by 2 is 2 all squared is equal to d plus 5 squared is 25 plus 4 squared, 2 squared is 4. So as we stand, x minus 5 all squared plus y plus 2 all squared is equal to d plus 29. So the coordinates of P is going to be here in the middle. That's going to be 5 and negative 2. So P's coordinates is 5 and negative 2. Right, find D. So now this here is R squared. D plus 29 is equal to R squared, am I right? D plus 29 is R squared. So let's go back. So we're now going to answer question number 2. So we got the coordinates of P. Now we want D. D plus, so it's x minus 5 all squared. I'm just going to write it here on the top. That's going to be our equation. X minus 5 all squared plus y plus 2 all squared is equal to D plus 29. Don't forget, you divided by 2, you got to square it on the other end. Right, find D. Okay. Now, we got a point there on the circumference, we got that. So let's join these two and make a radius. So let's find the distance PB. I'm answering question number 2. So PB squared, which is also R squared, is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So PB squared, which is R squared, this is also R squared. Remember, that's also R squared. PB squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So PB squared is equal to 3 squared is 9 plus minus 8 squared is how much? 64. PB squared, which is R squared, is equal to 73. Yes or no? So we got R squared is equal to 73. And we got R squared is equal to D plus 29. Onliners, are you with me? What happened there? I don't know what is this problem. What happened there? Like? I'm not neglecting you. I love you guys. Onliners, it's just that Khalid is not feeding me what comments here. I can't see. Khalid, you take your laptop, put it right here so I can see all the comments as they come in live. I'm going to throw you under the bus, brah. Right, so we got R squared is equal to 73. We just found out that R squared is equal to 73, and we also got R squared is equal to D plus 29. So that and that will cancel. D plus 29 is equal to 73. D equals 73 minus 29. D equals how much? 73 minus 29? 44. There we go. D is equal to 44. Did you all get D is equal to 44? Onliners, did you get D is equal to 44? There's mango fish. Khalid, wake up. Khalid, they're putting you here. So what did we say? R squared was equal to 73. So R is the square root of 73, right? R is the square root of 73. Okay. Find the equation of the tangent RBT. So now I'm going back here. Go back to your original is equal to root 73. Find the equation of the tangent. So we're answering question number 3. Let's do it in red. So firstly, we're going to find the m of our radius. M of your radius is equal to y2 minus y1 over x2 minus x1. That is equal to minus 8 over 3. Therefore, the m of your tangent is equal to 3 over 8. Why? Because your radius is 90 degrees to your tangent. Therefore, the equation of your tangent is now going to be y minus y1 equals m into x minus x1. So y, now we have to use that point. Minus 6 is equal to 3 over 8 into x minus 2. Y minus 6 is equal to 3 over 8x minus 3 over 4. Your final answer for the equation of your tangent, y equals 3 over 8x minus 3 over 4 plus 6. Minus 3. Man, fish, are we alive? Minus 3 over 4 plus. Is he alive?
He's saying his calculator betrayed him. He got negative 44.
For what? Plus 21 over 4.
And the rest of the guys on the chat, you can participate. Try sending us your answers as well, not always the shout outs. We need to know that you are keeping up with the work we are doing.
So the m of this line here we just found is 3 over 8. Very important. Whatever answer you get here, throw it onto your diagram. It's going to help you in the further questions down the line. Are we all on the same page? Right. Find angle theta. Find angle theta if the gradient of Ln equals a half. So Ln's gradient, the gradient of this line is equal to a half. We're answering question number 4. Go for it, guys. Find angle theta if the gradient of Ln equals a half. Now we know we can call this angle here angle theta 1. We can call this angle here angle theta 2. I can then 180, that is equal to that plus that. So I need to find this angle, I need to find that angle. I also need to find this angle here, from here to here. Let's do it in a different color so you can see it nicely. From there to there. No, let's go a bit darker. From here to here. I need to get this angle here, because if I get that angle there, I'll get that angle there. Then exterior angle, here's a triangle in the middle. I can then use exterior angle of a triangle is equal to sum of interior opposite angles. So I need to find what is angle theta 1 first. So I'm going to say tan of angle theta 1 is equal to the m of line Ln. Tan of angle theta 1 is equal to a half. So angle theta 1 is equal to shift tan a half. We get 26,56, 26,6. But remember, theta 1 theta 1, that big angle there, is an obtuse angle. It's an obtuse. So theta 1 is equal to 180 minus 26,6, which is equal to 153,3. No, I don't know. 180 minus 26,6. 153,4. So this angle here outside is 153,4. So this angle theta 2, therefore angle theta 2 is now equal to the 26,6. Angles on a straight line, adjacent, supplementary. So we got theta 1, we got theta 2. Now I need this angle here. If you want to, you can call this angle theta 3. If you want to, you can call that angle theta 3. So theta 3 is going to, m of this line, tan of theta 3. You took this one down, so we got 26,6. Theta 2 is 26,6. I'm going to write it here. Theta 2 equals 26,6. Let's erase this. Now let's find out theta 3. That's that angle there. Tan of angle theta 3, because this angle and this angle are vertically opposite, is equal to the m of line RT. Tan of angle theta 3 is equal to 3/8. So theta 3 is equal to angle of inclination. Shift tan 3/8. 20,6. 20,6, 20,6. It's acute, we leave it. Theta 3 is equal to 20,6. We want angle theta here outside. That's the angle we want. Exterior angle equal to sum of interior opposite. Therefore, angle theta is equal to theta 2 plus theta 3. Theta 2 is 26,6 plus 20,6. Theta equals 40. What's it? 26,6 plus 20,6. 47,2 degrees. There we go. Done. That's 5 marks. Yebo. Hey, well done. 46,12, it's fine. 47,12, it's fine. It's fine, mango fish. Even if you just put 47, that's fine. Another circle with center 10 and -4, and the radius of 6 is drawn. Will the circles intersect at 2 distinct points? Now, that again now against that set of rules. So we need to calculate. So in the last one, we've got our center is 5 and -2. Radius equals √73. In this one here, we got 10 and -4, and we got radius equals 6. Right. Distance between centers. So your distance between centers will equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So the distance between centers will equal to 5 squared is 25 plus -2 squared is 4. Distance is equal to square root 29. Sum of your radii. Now distance between square root 29, root 29 as a decimal will give me 5,38. 5,4. The sum of your radii is going to equal to root 73 plus 6. Root 73 plus 6. Boom, we get 14,54. That's your sum of your radius. So your distance between centers is less than your sum of your radii. Therefore, yes, they will intersect. Therefore, yes, they will intersect at two distinct points. You do it by calculation. You don't go there on your graph and go and try and draw another circle and see whether the two are going to. You do it by according to these rules. Okay, yesterday I gave you your rules of reflection. I just want to, do you guys still have your rules of rotation? If they ask you to rotate a point, do you remember this from grade 10? No. Rotation rules. Let me just give you rotation rules quickly. At least you can have it. Learn it. Because they can tell you a point is rotated about the origin 90 degrees in an anti-clockwise direction to give P dash. Find the new coordinates. I've seen it in a paper where they ask rotation in grade 12. The last time you saw it was in grade 9. Who remembers your rotation rules? Nobody. Just put it down. It's just having it in your toolbox of knowledge. You remember it exactly the way I'm writing it down. So let's take a point P, 5, and 2. Right. We're going to rotate it 90 degrees anti-clockwise, then 90 degrees clockwise. Then 180 anti-clockwise, 180 degrees clockwise. Right. 90 anti. The two swap over. P dash 2 and 5. But the X sign changes. So swap the two, swap X and Y, and then change X sign. 90 degrees clockwise, P dash, swap the 2 over from the original, 2 and 5, but the Y sign changes. Swap X and Y from the original, swap X and Y, and then Y sign changes. (180 anti or 180 clock is the same thing, P dash. They stay in the same position. Both signs change.
Thank you, Luniko from Emanyano, who is saying, I
There we
want to thank this program. I'm doing grade 10, but I want to take this opportunity to thank Mr. Kota. I am from Manyano High School. I am doing pure maths, but I got my best code on my mathematics through this
Well
program.
done, well done, well done, well done. Thank you for all the positivity, guys. Thank you for all the positivity. Our onliners, are we good? Please take these rules down, add it to your toolbox. Right. Let's end up with one last component here in circle analytics, and then we're going for break. It's 10 past 10 already. The last, we'll do one small component where I'll ask you to calculate the area of one triangle divided by the area of another triangle. The ratio of an area upon an area. You've seen that one before. Yes, please. You think I'll ever say no for coffee? Can I raise, guys? You took these rotation rules down? Good. Right. Let's make up one here. Let's make up one. Let's give you something like that. Let's give you something like this. And like that. And like that. Right, take this one down. That's 0. Point P, Q, R. That's your y-axis. That's your x-axis. P, Q, R, S. I'm just trying to think. Right. Let's say this is 2 and 20. Let's say this is 6 and minus 12. Let's say this point here. Minus 8 minus 4. Question number 1. That's minus 8. And then let's say that's minus, Q's coordinates is minus 4 and Y. Question number 1. Is SQ a perpendicular bisector of PR? Show all calculations. Number 2, we want the area of triangle PRS over the area of triangle QRS. So I'm just trying to think, was that first question correct? Because if I told you y equals, remember something, that question there, y equals minus x plus c, y equals minus x. In fact, put this point here as 2. Put this point here as 2. Put that point as 2. In order for it to be a perpendicular bisector, the gradients multiplied by each other must equal to minus 1. Or you can use midpoint first to show that is this distance equal to that distance. So you can either go the perpendicular route, or bisector, you can go the midpoint route. Whichever route you want to go. Which route do you want to go? Let's find the length of RQ. We can find the length of PQ. Or, no. I say let's go the midpoint route to find out where the Q is the midpoint of PR. So the midpoint of PR is equal to x1 plus x2 over 2, y1 plus y2 over 2. So 2 minus 8 is minus 6 over 2. 12 minus 4 is 16 over 2. That will give me minus 6 over 2 is minus 3. 16 over 2 is 8. Therefore, Q is not the midpoint of PR. Therefore, SQ not perpendicular bisector. Okay. Now, find the area of triangle PRS. This is the last question we're doing before we're going for break. We come back from break, and we're going to start with trigonometry, compound and double angles. Hier gidang. Hier gaat ons. People are working, brah. People are working. Right, go for it. The last one for analytics and circle analytics. Guys, I'm not going to touch data handling, really mean, median, mode, standard deviation. Come on. Don't play games. You've done hundreds of it in school. It's copy and paste. It's just formula. So make sure you get full marks in data handling, 20 marks. Make sure you get full marks in the 2 analytics questions, 20 marks, 40. You're already sitting with 60. I just want to see something. 60 divided by 150. You already got 40%, even if you left out everything, the rest of your paper. So those of you who are just aiming for 40, then just do data handling and analytics and get full marks. And then sleep. Right, let's go. The area of triangle PRS, let's go. PRS over the area of triangle QRS. So I'm going to use this as my common angle. I'm not going to use that angle there and then this, because there's no common angle if I use that one there. I'm using this as a common angle so I can cancel out these 2 angles. So that means, let's find out what is the distance of PR. Right, so PR is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So PR is equal to the square root of 10 squared is 100, 24 squared, so it's the square root of 100 plus 24 squared. I get 26. PR is 26. Right, now I'm going to find out RS. This was 6, ne? So RS is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. That gives me the square root of 6 plus 8 is 14 squared plus minus 8 squared is 64. 2 root 65, 16,12. Right, that's RS. Now I need QR. QR is also x2 minus x1 all squared. X2 minus x1 all squared plus y2 minus y1 all squared. That will give me 4 squared is 16. So that is the square root of 16 plus 2 plus 4 is 6. 6 squared is 36 equals 2 root 13, which is 7,21. QR. Now I need RS. No, I got RS again. So we had RS because it's a common side between both the triangles. Okay, so the area of triangle PRS is equal to half of a side times another side times sine of the included angle, sine R, divided by area of triangle QRS is also equal to half of a side RQ, 7,21 times 16,12 times sine R again. So this is equal to half and half will cancel out. Sine R and sine R will cancel out. So 26 times 16,12 equals 419,12. 419,12 divided by 7,21 times 16,12. Boom. 116,23. 116,23. 419,12 divided by 116,23. Your final answer 3,6. Done. Okay, it is 10:23, almost going for 10:30. So it's 5 minutes earlier than yesterday. Yesterday I took you 5 minutes into it. Guys, it is 10:30. We are here from 8:30 in the morning. We have done our first 2-hour bumper session. We did so much in calculus. We've done so much in analytics and circle analytics. Boys and girls, give yourselves a nice round of applause for this morning. Yeah, you can cancel. Yes. Okay, that was a bit stupid also. I could have cancelled that and that also. That I didn't see that. But that over that will still give you your 3,6. Yes, Umera. Okay, guys, we're going for break now. I shall see you guys back here at 11 o'clock. You got 35 minutes. Quick break, 11 o'clock. You're coming back in. And we are starting with trigonometry. And that will take us to lunch. Remember, you're getting world famous beggars for lunch. Enjoy your break, guys. Enjoy your break. Thank you, Umera, for that. go, let's go. Are we back, onliners? Are we back? Everybody back in the house? We are back, we are back, we are back, guys. Let's go, let's go, let's go. Right, take your seats. Let's get started with trigonometry. Right, please, you got to know your compound and double angles here. Number one, you need to know how to simplify. Number two, you need to know how to draw a triangle on a Cartesian plane or complete a triangle. We need to know reduction. We need to know identities. We need to know general solution. You need to know your non-90-degree triangles. And you need to know your trig functions. Okay, here we go, guys. Here we go. Now remember, we're starting off. So, onliners, are we back? Khalid, let's get our comments in from our onliners. How are we doing, guys? How's our onliners doing? Let's get our comments coming in.
Nabila
Onliners, are we
Isak.
back?
I'm seeing Nabila Isak for the first time this weekend. Saying
She was
salams,
in yesterday.
people.
I
was
think
in
she missed the
yesterday.
first session this morning. Right, let's go. Simplify. Simplify. So we got sine theta plus 30 minus root 3 sine theta plus 60. Let's go. Let's go, grade 12s. We're going straight into this. Now, learners who were part of our all-nighters last weekend, you'll find that today we're doing very different problems as well. So today is not a repeat of what we've done last time or last weekend. Today is going to be a test on your readiness for your exam. So what I try and do in every workshop that we have is try and give you a variety of problems and not do the same problems every workshop, so that it keeps you coming back for more, number one. And number two, it keeps you on your edge. It keeps you on your toes to see whether what we've done last weekend, whether you can apply to different scenarios this weekend. Right. We're going to do some cracker ones today, mango fish. You in for a treat. I chose these today also specifically because I knew a lot of the learners who joined us last weekend will be joining us now this weekend. So they don't want the same stuff. So we're not duplicating. Right, let's go. So we're going to do a little bit of everything here today. Let's do this together. Compound angle, sine of a compound angle, sine cos, cos sine. The sine stays the same, theta 30, and the sine stays the same. Minus root 3. There's a root 3. Now please open up the brackets here. That again is going to be sine cos, cos sine. Theta 60, theta 60. And the sine stays the same. This is equal to sine 30, sine theta, cos 30, sine 60, root 3 over 2. So I'm just going to go here. I'm going to say cos 30 is root 3 over 2 sine theta plus sine 30 is a half cos theta. By now, grade 12, you should know your special angles by memory. Don't even go into your calculator. Know your special angles. Minus root 3 cos 60 is sine 30, which is a half sine theta, plus sine 60 root 3 over 2 cos theta. Now, let's remove. So we got root 3 over 2 sine theta plus a half cos theta minus, let's multiply this out, minus root 3 over 2 sine theta. Negative times positive is root 3 times root 3 is 3 over 2 cos theta. Now collect your like terms. Root 3 over 2 sine theta minus root 3 over 2 sine theta is 0. A half minus 1.5 is minus 1 cos theta. Your answer is minus cos theta. So they could ask you to simplify this, or they could ask it to you as an identity and ask you to prove that that is equal to minus cos theta. Same scenario. Three to 4 marks on this problem. The next one, in fact, the next two are going to be very interesting. Onliners, you're going to love it. Our full-time students at our institute, you're going to love the next one. In fact, the next two. Very interesting ones coming up. Okay, but before I do that, let me give you something similar to what I showed you this morning. Okay? Now, if I didn't show you that this morning, you would have suffered now. If I didn't show you the one that I came up with last night in my dreams. Hey, imagine, because this one here that I saw now, I only saw it now during the break. While I was on break now, having coffee, I was going through it and I saw this one and I said, damn, this was my last night's dream. Right. Right in terms of theta. Right in terms of theta. So here's the one. Sine theta over 2 cos theta over 2. That's the question. This was my dream question. So do it like the way I showed it to you this morning. Multiply this by 2, so it's a half times 2 sine theta over 2 cos theta over 2. I swear I never saw this one last night. God loves us. So now half times 2 will give you the 1 like we did this morning. So this becomes half sine 2 theta. That's your sine double angle. So it's 2 times theta over 2, which is equal to a half. 2 and 2 will cancel, a half sine theta. Yay! Here's it from a past paper. From a past paper. Hey, God loves us. Don't worry, we are okay. I'm not going to hell for a light. Ish. Right, that one's done. Onliners, did you get it? Yes, absolutely. Let's go, next one. All right, sine 54, simplify. Sine 54 over sine 18 minus cos 54 over cos 18. Let's go, have fun. 4 to 5 marks. Ooh, and the next one is fresh. The next one is fresh. Now this one here, let's do the algebra. Your LCD would be sine 18 cos 18. Sine 18, so cos 18. So sine 54 cos 18 minus cos 54. Cos and cos will cancel, sine 18. Sine, cos, sine. Which rule is it? Which compound angle? Sine compound or cos compound? Sine. The sine stays the same. 54 minus 18 over sine 18 cos 18. Sine. What is 54 minus 18? 36. Over sine 18 cos 18. What's the relationship between 18 and 36? 36 is what? 2 times 18. All over sine 18 cos 18. That's your double angle for sine. 2 sine 18 cos 18 over sine 18 cos 18. Boom, 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 boom. What's your answer? 2. Agreed, grade 12s? Lots of fun. Tricks is fun. Onliners, you got it? Yes, Abdullah. Yusuf Abu, you in? Yep. That's it. My guys are on fire here. Like you in. My guys, my guys. Absolutely. That's why I need that right here so I can see all my live comments coming in. It's Khalid. It's Khalid. He's neglecting. He's making me neglect you guys. Blame him. Throw him under the bus. Set him on fire. Right, you done with that? Let's go. Next one. Right. Show that 1 minus 4 sine squared 15 is equal to minus 1 plus square root 3. Let's see how sharp are you. 5 marks. 5 marks. K-way is the only way. Away! Hey, you can't say that here. This is the Awqaf program, brah. That's why I didn't use my name anywhere. Wrong, haram, evil. Let's see who's the boss. Come, 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 come. These are challenges now. This is time to make that brain, the brain juices flow, Baba. Nablux, you in. Humaira, you in. That's it. Oh, what Nico Mabasa says, can you do this online lesson till we start writing? Of course we can. But nothing for Mahala. You pay, Baba, you pay. After today, you pay. Right, left hand side, let's have fun. Let's have fun, let's have fun. Right, now we know, listen to this. Now we need to use our brains. This is out of the box thinking here, brah. Okay, let's take left hand side on its own. Come, 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 come. Apply your mind. So if I take one minus 2 sine squared 15 is equal to cos 2 times 15. Yes or no? Okay, play around. Have fun. Start off with this. Start off with this. I got a way of doing it. Let's check if they did the same way. Go for it, go for it, go for it. Yes, I started it the same way. 1 minus 2 sine squared 15 is cos 30. Correct. Correct. Ah, beautiful, beautiful, beautiful. I'm a happy man. I am a happy man. Maths makes me happy. I need to be put into an institution. Yeah, I really do. You'll come visit me. Promise. We'll talk maths whole day. You are laughing. My friend, when I get put into the hospital, they're going to put me next to your bed. You will be there first before me. Okay. Now, we know that 1 minus 2 sine squared 15 is cos 2 times 15. Right? That's your cos double angle. Therefore, 1 minus 2 sine squared 15 is equal to cos 30. So 1 minus 2 sine squared 15 is equal to, what is cos 30? Sine 60, root 3 over 2. Right, now wait, now watch. Here comes the magic. Onliners, onliners, where to from here? Yusuf Abu, Mango Fish, Nablugs, Humaira, where to from here? Talk to us. Hey, they are quiet.
Does Awqaf offer mental consultation?
Yeah. 10,000 an hour. What do you think? You think this thing comes for free? Right, now watch. Minus 2 sine squared 15 is equal to root 3 over 2 cos 30 sine 60 root 3 over 2 plus 1, minus 1. Right. Now look. Now look. Now we need 1 minus 4 sine squared 15. So we got a minus 2 here. So I'm going to multiply this by 2. So that will give me minus 4 sine squared 15. Therefore, minus 4 sine squared 15 is equal to, we multiply that by 2, we multiply that by 2. So 2 and 2 will cancel out. I'm left with root 3 minus 1 times 2 is 2. So I'm just going to write it here on the top. Minus 4 sine squared 15 is equal to root 3 minus 2. Now we need a plus 1 there in the front. So add 1 to it. So that therefore 1 minus 4 sine squared 15, that's what they want. That's what they want, is equal to minus 3, root 3 minus 2 plus 1. Here's your final answer coming up, because we had to prove that that was equal to root 3 minus 1. Remember? Therefore, 1 minus 4 sine squared 15 is equal to root 3 minus 1, which is equal to right hand side. Got it? Got it? Got it? Nabla, Humaira, onliners, on-siters. You see, what I did first was got minus 4 sine. We had to start off with our identity. Our identity is the 1 minus 2. So I put it in terms of minus 2. Then to get a minus 4, we multiplied it by 2. What we did to the left-hand side, we did to the right-hand side. Then we needed a 1 on this side. So we included a 1. Added a 1 on this side, we added a 1 on that side. So minus 2 plus 1 gives you your minus 1. And that's you get left-hand side is equal to right-hand side. Mental. Mental. Done and dusted. They are sitting there. Some of them look like they've been hit by a bus. Sorry, man. That's what, this is my job. I get paid to destroy you. It's my job. If I show you the same you see in school, what is the purpose of you spending a weekend with me? Eh? Are we winning? I'm destroying you. Sorry, man. Excuse me. It's my job. I'm just doing my job and enjoying destroying you. Remember, I want you to walk out from here and say, I walked out with 10 times the amount that I walked in with. Then I know my job is done. Now you know how much you need to go home and study. Some of you are quitting after this. Some of you are just saying, every man for himself, God for all. What will be, will be. Maths, dala wajumas. Some of you are going to have math. I'm telling you. You know, my nightmare, your nightmare is math. My nightmare was Afrikaans, bruh. Till today, I'm 50 years old. Sometimes when I'm dreaming, I'm still dreaming I'm in school, and that teacher of mine, she was just making me fail, and everybody is passing and I am failing. Maths is going to haunt some of you. No, it will never leave you. Don't ever think that as you grow older, you're going to forget math. Now, this experience, you will remember. If cos 10 equals P, find the value of sine 20. Find sine 20. That's the easy one. Sine 20 in terms of P. Go for it. Go for it. Go for it. I got some cracker ones coming up. This is easy. You know what to do here. I hope you know what to do here. Then I'm going to give you one cracker reduction problem also to do. We'll do one reduction one after this. Oh, we got some killers. No, we're going to do two reductions. Right, the first thing you do, you make that P over 1. The minute they give it to you in terms of an alphabet, you have to draw a triangle. You do know that, right? Right, question number 1, find sine 20. Question number 1, find sine 10 in terms of P. No, sine 5. In terms of P. Two questions here. So that's 10 degrees. Cos is adjacent over hypotenuse, so that's P over 1. So that is by Pythagoras, square root of 1 minus P squared. Yes or no? You have to do that. Right, question number 1. Sine 20 in terms of 10. What is the relationship between that and that? So that is sine 20 is 2 times 10, which is equal to 2 sine 10 cos 10, which is equal to 2 sine 10. Sine is square root 1 minus P squared times cos 10 is P. So bring the P to the front, don't leave it at the back. So it's 2P square root 1 minus P squared. That's your first answer, you'll get 3 marks. 2P root 1 minus. Yeah, boy, yes. Yeah, yes. Now do the next one. The first one is worth 3 marks, the next one is 5 marks. Total marks, 8. You get the second one wrong, you fail the question. You know how maths does. They'll give you, and they'll give you one day at the end. That is like 50% of the higher order one. That is 50% of the whole question. Just when you thought you were winning, you are losing. Hey, this is abuse, nah? Sorry, nah? No, don't worry. I felt the same like you until I got 100% for maths and I made it my career. So I am abusing maths. I've made it my life mission to abuse maths for the rest of my life. Till the day I die, I will kick maths in its mouth. It hurt me a lot in school, serious. But you know, You just need to be like Popeye. You know, but you guys don't know those old cartoons. I don't know what crap cartoons you people watch today. Anime or you watch, there's no more Ben 10. We used to watch Popeye. Now you know who was Popeye. You don't know Popeye. Popeye used to drink spinach. You see, he drinks spinach, his guns become big, and then so you just need to, you take a can of spinach, get the ions, and then you go and fight. Huh? Right, sine 5. Now watch this. Watch this. To get sine 5, here's the trick. We start off with cos 10 equals P. So now how do I get a 5 degrees from a 10? Is 2 times 5 equals P. Now, in terms of sine, there's a cos double angle. 1 minus 2 sine squared 5 equals P. Now we make sine 5 the subject of the formula. Minus 2 sine squared 5 equals P plus 1 minus 1. Divide by minus 2, divide by minus 2. Boom, boom. Sine squared 5. You always start off with cos of the angle, even if they want a sine. Then you make it, this is half an angle. Half of 10 is 5. So sine squared 5 is equal to, so negative divided by negative is a positive. So that's 1 minus P over 2. So therefore, here's your final answer coming up. Sine 5 is equal to the square root of 1 minus P over 2. Right. There we go, there we go, there we go. Onliners, did you get that? Onliners, did you get that? Fantastic. Right, let's give you 2 reduction problems to do. Let's give you 2 reduction problems. Learn this. Learn well. All right. So whenever they give you half an angle, 5 is half of 10. You start off with cos of the double angle. And then you convert it to sine. Cos of the double angle, convert it to sine, and make sine of that angle the subject of your formula. Don't forget. Don't forget this, grade 12s. Right, let's give you quick 2 reductions. I know many of you have finished this one already. Let's go. Right, simplify. Right, sine x minus 90 into cos minus x plus 10, 360 minus x times sine minus x. Easy stuff for 4 marks. Go for it. While you're taking this one down, I'm looking for the next one. If we have enough time today. We can only do how much we can in the time that we have. Because this tricks is going to take us right through until lunch. After lunch, we're going to come back. We're going to do Euclidean, and then I want to do some sequences and series as well. I want to wrap up today. Okay, so let's see. Sine x minus 90. Now watch. Many of you don't know what to do here. Sine 90 will change to cos x. Remember 90 and 270 changes the name. Now be careful. Sine is in this quadrant. We're moving 90 degrees anti-clockwise. So we go from there to there. What is sine in this quadrant? Negative. Into. Cos of a negative angle is positive. That negative will fall away. Sine of a negative is negative. Tan of a negative is negative. But cos of a negative is positive. Don't forget that. Tan 360 will remain tan x. 360 minus is in your fourth quadrant. Tan in your fourth quadrant is negative. Times. Sine of a negative angle is minus sine of that angle. So we left with minus cos x into cos x. Negative times negative is a positive. Tan x is sine x over cos x times sine x over 1. Now, minus cos x into, that's over 1. So we left with cos x over 1 plus cos x. Sine x times sine x is sine squared x. My goodness, where are we going with this one? That's over 1. Okay, let's see. If I multiply this out, I get minus cos squared x minus sine squared x cos x over cos x. That and that will cancel out. I get minus into, if I took out the minus sign here, I get sine squared x plus cos squared x, which is equal to minus 1. Done. Right, guys? Onliners, we okay? Got that one there is minus 1? Right, one more. Last one. Bit of a hectic one, hectic reduction. Not too bad. I'm sure you guys will all manage it. For those of you who have taken this one down, you can already start taking the next one down and start working on it. Tan 540 plus x, tan 540 plus x, cos 180 minus x into cos 90 plus x plus sine squared 90 minus x over sine minus x. Prove that this is equal to 1. Prove. That is equal to 1. Have fun. Start. Knock yourselves out. Left hand side. While you're taking that one down, I'm looking for another one here. Oh yes, these ones are coming up. The next two are also very popular. Then we'll do a couple of general solutions.
I'm looking for the students I spoke to yesterday. The third one. Not here.
Come guys, this thing is chips. Easy peasy. Come, guys. You're looking at me. You're not going to get the answer by looking at me. You are suffering. Come on, guys. Easy peasy lemon squeezy. Stressy, messy, lemon zesty. Let's do this. Right. First thing we do, we take minus 180 from there. So 540 minus 180 is 360. Tan 360 will still remain tan x. 360 plus is in your first quadrant, tan is positive. Cos 180 will remain cos x. 180 minus is in your second quadrant. Cos in your second quadrant is negative. Multiply by cos 90 will change to sine x. 90 plus is in your second quadrant. Cos in your second quadrant is negative. Sine squared 90 will be cos squared x. We don't need to check whether it's positive or negative. Anything squared is always positive. Over sine of a negative angle is minus sine of that angle. Okay, so this one here on the top is positive. This one here at the bottom is negative. Positive times negative makes it a negative. Let's see. Have we reduced correctly? Right. Tan x is sin x over cos x times minus cos x over 1 into LCD here is sin x. 1 into sine, sine times minus sine is minus sine squared x, minus sine into sine once, 1 times cos squared is cos squared x. Now, positive times a negative is a negative. That and that will cancel out. You're left with sine x over 1 into minus into sine squared x plus cos squared x over sine x. Negative times a negative is a positive. Sin x over sin x will cancel. Sine squared plus cos squared is my right-hand side. We don't think we're right. We know we're right. Prove. Cos 6a plus cos 2a is equal to 2 cos 2a cos 4a. 2 cos 2a cos 4a. Start with that one. Left-hand side. Let's start with that. Yeah, Abdullah, last one was chips. And no small flops. How far? How do we do this one? Watch here. Put your pens down. Your right-hand side tells you your two reference angle, a 4A and a 2A. So on your left-hand side, cos 6A in terms of a 2A and a 4A is 2A plus 4A plus 2A here is cos 4A minus 2A. Are you all with me? Don't break this up as your cos double angle. And you can't say here 5A plus 1A or 3A plus 3A. No. Your right-hand side will tell us how to break it up. So 6A is 4A plus 2A, 2A, 4A minus 2A. Shh. Come, guys. Right. This now, cos, cos, sin, sin, 2A, 4A, minus 2A, 4A, plus that, cos, cos, sin, sin. 4A, 2A, 4A, 2A, and that becomes a plus. Right. Minus sine 2A sine 4A plus sine 2A sine 4A is out. 1 cos 2A cos 4A plus another 1 cos 2A cos 4A is 2 cos 2A cos 4A, which is equal to your right-hand side. You guys got that one right? You guys want oxygen breaks. What's our time? How's our time looking? Now we still got good time. I'm going to give you now. Ooh. They want the general solution of this. Let's check these. Okay. Can I raise? Take it down quickly. Right. You guys want a killer general solution. These people are crying. These people are crying. The next one's rough. The next one is rough. While you doing this one, I'm taking my 5-minute oxygen break. Right, I want the general solution. Killer one. Oh, come on, man. Right, let's go. Sine 3a minus sine squared a equals 0. For 7 marks, I want the general solution. Right, Luyanda says, bring it on. Right, let's go, let's go, let's go. Onliners, let's check. Let's check what fire, how much fire you still have. Turning this laptop here so I can see your comments coming in live time, in real time. I'm going for my oxygen break outside. I'll see you in 5 minutes. Dala what you must.
Ukhona umuntu ofuna uyofunda e-DUT eDurban. Ufuna ukwenza ntoni uyeso omngaka? Nifuna ukwenza ntoni eDurban? Xa ukhetha iyunivesithi, ukhetha iyunivesithi especialize le nto ufuna uyenza. Suya nje kuba iseDurban uzaba kude bazalini. Baza kudlala abafana eyunivesithi. Ufuna ukwenza ntoni e-DUT ayiphumi because sometimes le nto ufuna uyenza e-DUT nalapha e-CPUT ikhona. Uhambe uyoprotesta apha e-CPUT. Ufuna uba kude kumama notata ebethunana. Niyazi kuyalanjwa eyunivesithi awufika utya ii-noodles phaya ubungapha uready? I'm gonna do that at break time, the lunch time.
How many you got?
I think it's more like 14 to 18, I'm not sure.
Okay. All right, I hope you guys are done. Half past 12. Half past 12, we'll go for break. So Khalid just said we've got some free gifts, some antiperspirants for those of you that are smelling. I'm lying. No, I'm lying. He got about 80 or 40 or 80. He's going to check. They're giving out some free gifts during the break. Some roll-ons and some sprays. About it's for Mahala. Just take and spray. Use it for air fresh. Air fresh. Right, here we go, here we go, here we go. No, like he was just saying, Khalid was saying they got some free gifts for the learners on site here. Some doom. Right. Yo, this thing is going to get a bit rough. We're going to break the sine 3a up into sine a plus 2a minus sine squared a equals 0. So this will be sine cos sine a 2a minus a 2a minus sine squared a equals 0. Let's break everything up in terms of sine. So sine a cos 2a is 1 minus 2 sine squared a minus cos a times sine 2a will be 2 sine a cos a minus sine squared a equals 0. Sine a times 1 is sine a minus 2 sine cubed a minus 2 sine a. Cos times cos is cos squared, and cos squared is 1 minus sine squared a minus sine squared a equals 0. Onliners, did you get that? Okay, so now sine a minus 2 sine cubed a minus 2 sine a, we're multiplying it out, plus 2 sine cubed a minus sine squared a equals 0. Minus 2 sine cubed a plus 2 sine cubed a cancels out. 1 sine a minus 2 sine a. So I'm left with minus sine squared a. 1 sine a minus 2 sine a is minus 1 sine a equals 0. Divide by negative, we're left with sine squared a plus sine a equals 0. Let's double check if we're right. A plus 2a. A to a. Ah, this was plus. Damn. That was plus. That was plus. That was plus. Oh God. Oh Lord. We are all out from there. Sure. You see how you can mess it up. There's a plus. There, because it's sine, the sign stays the same. Am I right? Cos a, sine 2a, correct. So sine a times 1 is sine a minus 2 sine cubed a plus 2 sine a. Cos squared is 1 minus sine squared a minus sine squared a equals 0. Sine a minus 2 sine cubed a plus 2 sine a minus 2 sine cubed a minus sine squared a equals 0. Let's go again. Minus 2 minus 2. minus 4 sine cubed A. That and that. Minus sine squared A. Sine A plus 2 sine A is plus 3 sine A equals 0. So 4 divide by negative 4 sine cubed A plus sine squared A minus 3 sine A equals 0. Now let's take out sine A as my highest common factor. 4 sine squared A plus sine A minus 3 equal 0. We're not yet done. We are not yet done. We are not yet done. Onliners, are we okay? Go right down to the last comment. There we go, there we go, there we go. I'm erasing here on the top. Let's go back. We got sine A into, let's break that up, equals 0. So we're going to have, what's it going to be? 4 and 1, 3 and 1, am I right? So it's going to be 4 sine A times sine A. And then that's going to be 3 and 1. That would be plus and that would be minus. Because 4 sine times sine is 4 sine squared. Minus 3 times 1 is minus 3. Minus 3 sine A plus 4 sine A will give me my plus 1 sine A. So now we got sine A equals 0, or 4 sine A minus 3 equals 0, or sine A plus 1 equals 0. Abdullah, mango fish, are we right? Are we right? Just turn the thing slightly this way so I can see. There we go, there we go, there we go, there we go. There we go. So A is equal to shift sine 0 is 0 degrees plus K times 360, where K is an element of integers, or A is equal to 180 plus K times 360, where K is an element of integers. Sine A equals 3 over 4. A equals shift sine 3 over 4, shift sine fraction 3 over 4 equals 48,6. 48,6 plus K times 360, where K is an element of integers, or A is equal to 180 minus 48,6, 131,4 plus K times 360, where K is an element of integers. Here, sine A equals minus 1, A equals shift sine minus 1, shift sine minus 1 minus 90 plus K times 360, where K is an element of integers. There we go. 3 solutions here for this one. Laik, are you managing there, brah? Laik say his hands are finished. He doesn't even know what to write anymore. Right, one last one. One last one. No, then I want to give you 1 or 2 very unusual general solutions to do. I'm going to give you 1 proof and 1 more general solution. Oh, no, I'm going to give you a killer one now. Like you managing the guy? Right, you guys got this? All right, for those of you who finish that, start the next one. Prove that 2 cos squared 45 minus a is equal to 1 plus sine 2a for 5 marks. And then I'm going to give you a killer. Then we're ending up this year with a killer. Wait, I just want to see another crazy general solution. Start with the next one. We got 2 more to do and then we are done with the trigs. Oh, Lord. Oh, my Lord. I don't like the way they did it here. I'm going to try the next one out quite differently to the way they did it. Anyway. I like to do it differently to the way the memos do it. Just my mental way of saying, stuff you. Sec. I hate memos, you know. They make me nar. They think they're too clever. Samurai. Give me your pen. I just want to put it here on my page. No, I took the one pen to keep on this page. I just want this here to keep here, just for now. Right. Right, 2 cos squared 45 minus a. That would be 2 cos squared. That's 2 cos 45 minus a squared. Bring that square to the front, to the top. That is 2. You can put that in brackets like that. So this would be cos, sine, squared. 45a plus. Now we need to prove that it's equal to 1 plus sine 2a. We need to prove that it's equal to 1 plus sine 2a. That's what we need to prove. So that's 2 cos 45, 1 over root 2 or root 2 over 2 cos a plus root 2 over 2 sine a all squared. That is 2 into, we're squaring a binomial. So squared, root 2 over 2 squared would be 2 over 4, which is a half, cos squared a plus a half sine squared a. Remember, I'm squaring a binomial. Multiply the 2 inside the brackets will give me a half plus, that's a half, times 2. We have to double it. Sine a cos a. Your middle term. That is equal to 2 times a half is 1 cos squared a plus 2 times a half is 1. 1 times 2 is 2 sine A cos A. Plus 2 times a half is 1 sine squared A. Sine squared A plus cos squared A is 1 plus 2 sine A cos A is sine 2A, which is equal to your right hand side. There we go. Done. Did it. Luyanda, done. So this one was done. Oh, now comes the fun. The next one's going to take us almost right through until break. The next one is going to, this one is a cracker. This one's a killer. So take a deep breath. Mango fish, I hope you're ready. Warm your hands. Let's go. The next question for 812 is 12 marks. Here we go. Right, this is where we're wrapping up trigs. Right, prove. Question number 1. It's broken up into many questions. Prove that 2 sine x minus y over sine 2y is equal to sine x over sine y minus cos x over cos y. Right. That's question number 1. Question number 2. Hence, this is all one question. Hence, show. Three questions. Question number 2.1. 4 cos 6y is equal to sine 15y. This is the time many people start quoting. Over sine 3y minus cos 15y over cos 3y. 2.2. 4 cos 36 is equal to 1 over sine 18. 2.3. Show. Right? You have to show. Remember, hence show all of these things. Show that sine 18 degrees is a solution for the cubic equation. (8k cubed minus 4k plus 1 equals 0. Have fun. Here you go. This is going to take us right through until break. Give it a go. Right, the first one's going to be quite easy. The first one's going to be quite easy. Let's look at the right-hand side. The right-hand side there is going to be sine y cos y. So sine y and sine y will cancel. Cos y times sine x is sine x cos y, minus cos y and cos y, cos x sine y. Right. Now I can multiply. So sine cos sine, sine cos sine is my sine compound angle, sine x minus y over sine y cos y. But they want a 2 in it. So multiply the numerator by 2, multiply the denominator by 2. Therefore, 2 sine x minus y over 2 sine y cos y is equal to 2 sine x minus y over, that's my double angle for sine, sine 2y, which is equal to your left-hand side. There we go. That's your first one. Who does this lot of marks? This entire problem is, okay, the first one here, that's worth 4 marks. That one's worth 4 marks. That one worth 4 marks. This one worth 5 marks. 4, 8, 12, and 5, 19 marks. It's like this. Right. Did you guys got it? You guys got it? Are you guys done? Onliners, you guys done? You got it. Right. Now do the next one. The next one's interesting. Remember, they're all related, eh? They are all related. No. Right, you took the first one down. Can I erase the first one? We proved it, right? Let's look at the second one. Now, the second one's rough. 2.1. That's that one there. So watch here. Watch here, watch here, watch here, watch here, watch here. So basically this here is the same. My right-hand side here and my right-hand side there is the same. So this here is going to be the same as this. So sine 15y, I'm just writing it out. Sine, therefore, sine 15y. There's it. 15y over sine 3y minus cos 15y over cos 3y will equal to this. Will equal to 2 sine x is 15y. X is 15y. There we go, 15y. That's x. That's y. That's x. That's y. So 2 sine 15y minus 3y over cos 2 times 3y. Four cos 36 is equal to 1 over sine 18. Right, let's see. So this is equal to, that means this whole thing that they wanted us on the right-hand side. Remember, we got to prove that it's equal to 4 cos 6y. So that's 2 sine 15y minus 3y is 12y over cos, it's 2 times y. What's y? 3y. So it's 2 times 3y, 2 times 3y, which is 6y. Is it sine? Oh yeah, sine over sine 6y over sine 6y. Right. So here's the 2. Here's the 2. Sine 12y is 2 sine 6y cos, that's your double angle for sine, cos 6y over sine 6y. Sine 12y is 2 sine, because this would be sine 2 times 6y. If you wanted me, I can break it up for you even further. Okay, so let's do this. Let me help you out. Maybe you missed that step. So let me show it to you. No, it's fine. I'm just making it. All right, let me help you out here. So the sine 12y is 2 times 6y over sine 6y. So this is 2 times sine, that's your double angle for sine. So that's 2 sine 6y cos 6y all over sine 6y. Now sine 6y and sine 6y will cancel. What am I left with? 4 cos 6y. There we go. Which is equal to 4 cos 6y, which is equal to left-hand side. Done. Did you guys get that one? Onliners, I know you're battling, I know you're sweating with these. These are higher order questions. Yeah, it's break time. I know it's break time. Okay, I just want to do the next one. I know it's break, guys. I know it's break. I know it's break now. I just want to do 2.2. We can do 2.3 after break. So we showed, remember all of them are related to each other. Eh? All these questions are related. This is one batch of questions. Right, pay attention. Pay attention. Right, now we're doing this one, number 2.2. Let's circle it in blue. We're doing number 2.2. We need to show that 4 cos 36 is equal to 1 over sine 18. If I make y equal to 6 degrees from the previous one, right? So if y is equal to 6, 15 times 6 is 90. 33 times 6, because how am I going to get an 18 from? So I'm going to say let y equal to 6 degrees. Because 3 times 6 will give me an 18. Right, I'm going to say let y equal to 6 degrees. Therefore, from the previous one, therefore, sine 15 times 6 over sine 3 times 6 minus cos 15 times 6 over cos 3 times 6. So this will give me 15. 15 times 6 is 90 over sine 18. There we go, because I want 18 degrees in it. Minus cos 90 over cos 18. Right. So what was 4 cos 36? Okay, what is sine 90? Is 1 over sine 18 minus cos 90 is 0 over cos 18. Yo, flip, I'm good, right? 0 over any number is 0. So here we go. 4 cos 36. Therefore, 4 cos 36 is equal to, what am I left with? 1 over sine 18. Just like a boss. Guys, did you get that? Guys, did you get that? Onliners, turn the stick. Oh, like you got it. Well done. Well done. Let's see how you get the next one. Show that sine 18 is a solution for the cubic equation. Anyway, we're going for break now. It's 12:35. I'll see you back here at 1:15. Guys, 1:15, we start again. Enjoy your break. Enjoy your break. Enjoy your break. I'll see you guys back at 1:15 to finish this one up. Enjoy your break, guys. Solid, solid. Abdullah, did you get it? Mango fish, did you get it? I know this was a cracker. This was a freaking cracker. Lovely, lovely. Well done. Yusuf Abu, you're a machine guy. Well done. I'll see you guys after break. Short, short. Khalid, can we go live? Sam, are we live? Okay, onliners, are we back? Get my screen up. Who you blocked from the chat? Owens are rolling here. Welcome back, onliners. How we doing? We are back. Get the comments in. Khalid, talk to us. Onliners, are we back from the land?
Guys, please settle down. Settle down. We are about to begin the last session.
Onliners, are we back? This is the final workshop for final. No. There's another one coming. End of the year. Guys, this is not the last workshop for the year. There's still one more to come, before finals. This is just the one before prelims. There's another one coming before finals. Onliners, are we back? I'm not getting any comments coming in. Maybe because you are all kicked out. My brah Khalid kicked you all out. But let's go. Mango Fish, where you, my brah? Now let's do this last one. Let's go. Right, now the last one here, guys. The last one. Time to see your ass again for the last one. I don't know why we put ourselves under this pressure. Right, let's go. We back. Okay. The last one says, show that sine 18 is a solution for the cubic function. Now, pay attention. Because all of these questions were part of one question, question number 2, right? Always look at the question before to try and answer the current question. So we're going to be left with 4 cos 36, right, is equal to 1 over sine 18. Right. Now let's look at the 18 here. So 4 cos 36 is 2 times 18 is equal to 1 over sine 18. From the last question. We're answering question number 2.3 by looking at 2.2. Mango Fish, are you in? Guys, are you all right? Mango Fish, Abdullah, are you ready? Laik, you back? Yusuf Ayob, are you in? Where's everyone? Right, let's go. So this is 4. Cos 2 times 18 is your cos double angle. It's 1 minus 2 sine squared 18. Is 1 over sine 18. So 4 times 1 is 4 minus 8 sine squared 18 equal 1 over sine 18. Right. Now what does this look like? Doesn't this look like the K method in algebra? Doesn't this look like the K method in algebra? So watch here. So now I'm going to say let sine 18 equal to K. Pay attention. Let sine 18 equal to K. So we got 4 minus 8 K squared is equal to 1 over K. Now multiply it all out, we get 4K minus 8K cubed equal 1. Kaching, kaching, minus 8K cubed plus 4 4k minus 1 equals 0. Look at that. Look at that. Shit's going down. It's happening here, Owens. 8k cubed plus 4 minus 4k. We divide by negative. Plus 1 equals 0. There we go. There we go. Therefore, sine 18 is a solution. Therefore, sine 18 is a solution. Because sine 18 equal k. And it's a solution. It's part of the problem. Is a solution. There we go. Woohoo! Yeah, I know. I know. It's math. All right. Before we do anything, I came across an algebra question. Now let's just flip it. I know you guys are sick of this already. Let's do an algebra question that I came across, and then we go into Euclidean. Right, just take your mind off certain things. When we take our mind off one thing, we don't start thinking about dancing and music. We just think of another topic in math. That's how we play. That's how we tap out. We tap out doing more math. Like, really? What's going on here? Who's calling us now? No, nobody should be calling us now. Right, let's go. Let's erase. Question that came out in a paper, an algebra question, show that, let's do this one, show that 1 plus x to the m, I don't know if you guys seen this one, 1 plus x to the m plus x to the minus n all squared minus 1 minus x to the m minus x to the minus n all squared is divisible by 2 for all real values of m and n. Is divisible by 2 for all real values, for all real values of m and n. That's an algebra question. Like, how can you be lost, brah? Where were you? You'll have to replay. If you lost, replay it. Go to the Awqaf web. Watch it over and over and over until you have mastered it. Answer. Right. What do we do here? Doesn't this look like the difference of two squares? Yes or no, guys? So this, how do we do the difference of two squares? What would we do? It's the square root of the first minus square root of the second. Wait, I need more space here. This here we need lots of space for. So in our answer, this is where we're going to start our answer. I'm going to put a bracket like that, and a bracket like this, and a bracket like that, and a bracket like that. This is the difference of two squares. So 1 plus x to the m plus x to the minus n minus 1 minus x to the m minus x to the minus n into 1 plus x to the m plus x to the minus n plus 1 minus x to the m minus x to the minus n. Let's just double check. So, square root of the first bracket is 1 plus x to the m plus 1 minus 1 minus x to the m minus x to the n into 1 plus x to the m plus x to the minus n plus 1 minus, but in brackets. Okay, this is equal to, let's remove the brackets, inside brackets. 1 plus x to the m plus x to the minus n minus 1 plus x to the m plus negative times negative is a positive x to the minus n into 1 plus x to the m plus x to the minus n plus 1 minus x to the m minus x to the minus n. Agreed? We just remove the brackets. Collect your like terms in the brackets. What do we have? 1 minus 1 is 0. X to the m plus x to the m is 2x to the m. 1x to the minus n plus another 1x to the minus is plus 2x to the minus n. 1 plus 1 is 2. X to the plus m minus x to the plus m is out. X to the minus n minus x to the minus n is out. So we only left with 2. So obviously if it's 2 times all of this, therefore, divisible by 2 for all real value or values of m and n. Done. Because you got 2 times the whole thing, obviously the entire thing will always be divisible by 2. Guys, you got it? Onliners, did you get it? Out of a past paper. I'll even tell you which paper this one came out of. What the hell? Ooh, Department of Basic Education, November 2024. This was a 2024 paper. This was a question that came out in November 2024. Right. Let's go into, I'm going to do one 2D diagram. One 2D diagram, and then we'll go into Euclid here. Now, please remember, I saw in one of the papers here, they even asked you the proof of the cos rule. Can you believe it? In grade 12, they asked you the proof of the cos rule. Sorry, nah. Just learn the proof of the area rule, sine rule, cos rule as bookwork. Just put there. Learn the proof from your textbook. I'm not going to do it with you, but just learn the area rule, sine rule, cos rule proof. I know they say, many times they say non-examinable, but I've seen it in the paper. Right. Now remember for 2D trigs, 2D or 3D trigs, 2-dimension, 3D trigs. Let's call it 3D trigs. Basic concept. For a 90-degree triangle, we all know we got to use SOHCAHTOA. For a non-90-degree triangle, to solve it, we either use the sine rule or the cos rule. That's it. 90-degree triangle, SOHCAHTOA. Non-90-degree triangle, sine rule or cos rule. You know sine rule. A side over sine of its opposite angle is equal to any other side over sine of its opposite angle. And the cos rule we know. A squared is equal to one side, the last side squared is equal to B squared plus C squared minus 2BC cos A. Let's go into the problem. Okay. Let's see what's our challenge for today. Okay. You got this down? Sine rule, cos rule for non-90-degree triangles. 90-degree triangles, SOHCAHTOA. Now let's see which paper did this one come out from. Northwest Prelim 2025. Northwest Prelim 2025. Okay, I think we're going to do this whole paper in terms of its Euclidean also. It's a bit of a rough paper. It's going to get hectic. Guys, your prelims are more difficult than your finals. Make sure your prelim marks are good. Right, let's start. Let's draw this diagram. It's not a difficult diagram. PAC, that's 90 degrees, that is B. That is small d, that is angle theta, this is H. They tell you in the diagram A, B, C are on the same horizontal plane. Point P is a balloon vertically in the air above C. The angle of elevation is theta. They tell you ABC equals 90 minus alpha. They tell you BC is equal to half AB. And they tell you AB equals D units. Right. Prove. Question number 1. Prove that H is equal to D tan theta square root 5 minus 4 sine alpha over 2. That's question number 1. Question number 2, find H. If D equals 300 meters, small a equals, alpha equals 32 degrees and theta equals 63 degrees. Right. First one is worth 5 marks, second one 3 marks, 8 marks in total. 5 marks, 3 marks, total marks 8. Now, whenever we have problems like this, the first thing we want to do is rename the common side. And they want H. Is that all that they give us? Yes, that's all they give us. Now they say ABC is 90 minus alpha. ABC is 90 minus alpha. BC is half of AB. So this is half of D, because AB is D. Sine, let's go 10. Because they want a tan theta in the problem, let's start with this diagram here. I'm going to say, let's find AC. I'm going to say tan of theta, that's what they want, tan theta, is equal to H over AC. H over AC. I want AC. So AC cross multiply tan theta equals H. I want AC. AC equals H over tan theta. So AC is now no longer called AC. AC is called H over tan theta. Right, guys? Onliners, we okay? Prelims are government. Prelims are not set by your district, but it's provincial, it's not national. Your province will set your prelim paper. So Gauteng will have its prelim paper, Northwest, each province will have its own common prelim paper for its province. District doesn't set it. Right. So, I'm just thinking. Don't you think we got two sides? Listen to me. We got two sides and the included angle. See here, we got a side, we got three sides, we got an angle. Don't you think we should, and because we got a square root in the problem, that generally tells us to use the cos rule. Guys, here's a clue. Because you know the cos rule says squared in the problem. So if you got a square root on the other side, it means somewhere there was manipulation of a square in a formula. That means the cos rule indicated it. Yes, Luyanda. So now let's use the cos rule in this triangle. It's going to get a little tricky, so you better make sure that your algebra is on point. So the last side squared, H, so okay, let's put it like this. Let's say AC squared is equal to AB squared plus BC squared minus 2 into AB into BC cos of angle B. AC squared is H over tan theta all squared is equal to AB squared, which is D squared, plus BC squared, which is half D all squared, minus 2 into D into half D, cos B is 90 minus alpha. Now let's do the math, let's do the algebra, and let's pray that we make, and let's make H the subject of the formula. After this, it's every man for himself and God for all. Let's go. H squared over tan squared theta is equal to D squared plus 1 over 4 D squared minus 2 times D is 2D over 1, right? So 2 and 2 will cancel. 2 and 2 will cancel. D times D is D squared. Cos 90 will change to sine alpha. 90 minus is in your first quadrant, cos is positive. I'm moving up because we don't have space. H squared over tan squared theta equals 1D squared plus a quarter. 1 plus a quarter is 5 over 4D squared minus d squared sine alpha. Let's take out d squared as the highest common factor. H squared over tan squared theta equals d squared into 5 over 4 minus sine alpha. Now let's multiply this side by tan squared because I need to get to h. That's all I'm doing. I'm driving to get to h. So h squared equals d squared tan squared theta into 5 over 4 minus sine alpha. When you're thinking, even your handwriting becomes neater. Okay, because we don't want to make a mistake. I can't do the same problem twice. I ain't doing it twice. I either get it right first time or I go home. Go big or go home. Once cut. Let's take that out. You all got that in. Let's continue. We need to get h. Therefore, h is equal to the square root of d squared tan squared theta into 5 over 4 minus sine alpha. So h is equal to the square root of d squared is d. The square root of tan squared is tan theta. There's d, there's tan. Now remember, in the bracket, this is over 1, right? So now you're still left with the square root of, your common denominator is 4, so we're left with 5 minus 4 sine alpha. Here, moment of truth, h is equal to d tan theta square root 5 minus 4 sine alpha. The square root of 4 is 2. 2 times, this is all over 1. So you can make the whole thing. Square root of 4 is how much? 2. There we go. That's our final answer. Right, guys? Did you get it? Onliners, did you get it? Find h if d is equal to 300 theta. Come on, that's so easy. Now all we have to do now is substitute 300 for d, 63 for theta, 32 for alpha, and you'll get your final answer. Onliners, are we okay? Did you get it? All of you. Don't mess up with your algebra here. This is just the cos rule. And we made h the subject of the formula. There we done. There we go, and we are done. So what you want to do is rename the common side. What did we do here? We renamed the common side. Boom. After we rename the common side, we just use the cos rule. We just use the cos rule to find h. Talk to us, onliners. How are we doing? Are you still there? Khalid, they cross with you, brah. Khalid, they want to slaughter you, brah. Okay, let's go into, right. Similarity and proportion. Please, guys, I'm not going to recap now. Grade 11 Euclidean. Come on, you guys know your grade 11 theorems. Grade 11 circles? Don't tell me you don't know. You know it? I hope so. Okay. Similarity and proportionality. Now remember again, let me just show you how we are going to tackle Euclidean. Under Euclidean for grade 12 in your paper, paper 2, please learn grade 11 proof, 10 chord theorem, exterior angle of a cyclic quad, line drawn from center of circle to midpoint of chord. Very important. Midpoint, line drawn from center of circle. Learn these proofs. Right. Then know, for grade 11, know all your theorems, how to apply. No application. Get full marks here. 30 marks. Or 25. Grade 12, know the proof of similarity. Proportionality, sorry. Proportionality proof. Prop proof. You got to know that. No Pythagoras. In a circle. And then no similarity. And that's going to give you your 50 marks. What did I say? Memorize 12 to 15 past papers. Paper 1 and 2. I know some of you are thinking, yo, you got hopes, sir. You got big hopes. You really believe in us. Get a past paper booklet and memorize the whole booklet. If you can do that, you're a boss. You're going to fly through that exam. Right, let's start. Are you ready? Okay. Shoot. Let's, wait, now don't draw just yet. Let me get this diagram right. Right, they give us a circle like this. They give us a line coming from there right down till here. Right, they give us a line going from there till there. They give us a line going from here till here. They give us a line going across. They give us a line going across. They give us a line going up there. They give us a line going down there. In fact, this line here goes right across till there. This line goes right across. Oh, shit. Supposed to go till there. Ah, God. How am I going to get this one right now? Okay, so we go till there. We make a plan. There we go. Right, that's a straight line. ABD, that's point A, point B, point D. E, G, that's a G, F. B1, B2, B3, H, A1, A2, D1, D2, D3, C, 1, 2, 3, 4, 5. Oh my Lord. C, 1, 2, 3, 4, 5. G1, G2, E1, E2. Right, let's go. In the diagram, ABCD is cyclic, EF is parallel to BD. EF is parallel to BD. They tell us EF is parallel to BD. Here we go. What do they say? ACG, DCE are straight line. That's all. Right, proof. Here we go. Don't wait for me. You guys can start. Number one, E1 equal A1. Angle E1 equals A1. Number two, EF is a tangent. EF, prove that EF is a tangent to the circle EAC. Number three, prove that triangle ABC is similar to triangle EDF. Number four, prove that BE times AH over GH is equal to ED times BC over DF. Mark allocations 3, 1, 4, 6. 3, 1, 4, 6. 6 and 4, this is 14 marks. There we go. Now, 3, 1, 4, 6. So that was 14. 14 and 7 is about 20. So 20 marks only will be on your grade 12 work, guys. So you can still score out of 50. You can still get 30 out of 50 for Euclidean. Let's go, guys. Prove that A1 is equal to, did you guys do this one? E1 equal to A1. Onliners, it's done. Supposed to be done. Number one, E1. What is, so let's do it in red. What angle is E1 equal to? Before we get to A1, there's no direct link. E1 is equal to D2, alternate angles. Question number one, angle E1 equals D2, alternate. Now, is there a relationship between D2 and A1? Yes, there is. Angles in the same segment, the butterfly, the bow tie, all 4 points touch the circumference. But D2 is equal to A1. Angles in the same segment. Therefore, E1 equals A1. Done. There's your first 3 marks. Yes or no, guys? Onliners? We're going to do 1 or 2 proportionality problems. I'm going to do this one. I'm going to do another one, another cracker one. Then we're going to do a proportionality cracker. Then we are done. It's 2 o'clock already. Before you know it, chai latte. Right, number 2. Right, so we got this angle equal to that angle is equal to that angle there. Prove that EF is a tangent to circle EAC. So let's go to circle EAC. EAC, that means there's a circle here. Oh God, no, it's not like that. It's How are we going to draw this circle? With this, they say EF. Oh, EF. You see? Stupid me. EF is a tangent to circle EAC. Now, it doesn't have to be a complete circle. It can look like a potato also. It doesn't matter. They're just telling you there's a circle around it. But what's important is that EF looks like a tangent to it. So obviously for it to be, at the minute they talk about tangent, look at the triangle that touches that touches the circumference. So we need to prove that E1 is equal to A1, which we just did in the previous one. We can say E1 equals A1 proven above. Therefore, EF has to be a tangent. EF is a tangent to circle EAC. It's the converse of your tan chord theorem. It's already proven. You proved it before. They just want you to recognize it. Yes, Layanda, you're so clever. Well done. Converse of tan chord. But this popcorn is lasting me all day, bruh. Only thing that's keeping me boosting. Come, guys. Right, now do the next one. Prove that triangle ABC is similar. A, B, C. Similar to triangle E, D, F. Okay. Right, let's go. Let's do number 3. So ABC, ABC, A, B, C. To triangle EDF, E, D, F. A1, B3 and 2, C2. E1, D3F. Now there is a shortcut. You can short circuit this whole question. Guys, come I show you a small trick. They already telling you that these two are similar. You need to prove it. Basically, they're already giving you the equal angles. Check it. You can work backwards with this. You can beat the examiner at their own question. You know how? Here's it. You already know angle A must equal angle D. You just need to say why. Angle A is equal to angle, so angle A here must equal to angle D3 here. No, sorry, angle A equal to angle E. Angle A from here. Look at the question. The question is already giving you the answer. You need to prove that angle A is equal to angle E. Have we done it? Yes, we have. Have we done it in the beginning? Yes, we did. Is angle B equal to angle D? Is angle B equal to angle D? Right, we didn't prove it. They're telling us it's equal. So yes, angle D3, is it equal to angle B? Is this angle, put a tick there, is it equal to this whole angle? Yes, it is. Exterior angle of a cyclic quad. Aha. So there we go. We already get it. And obviously, C will equal to angle F, remaining angle. This angle here will equal to that angle. So you don't need to look for the answers. The answers are there. They're telling you they're equal. Just state the reason. We're working backwards to beat them. Right. So now we go. In triangle ABC and triangle EDF. Can you see what I did here? I split the two triangles up. When you split triangles up, it's similarity. It's not proportionality. When you're working with separate triangles, it's similarity. SSS. Split, similar, separate. P for parallel lines, P for proportion. So whenever they give you parallel lines in a triangle, proportionality. So question number 1, angle A equals angle E, proven above. Number 2, angle B equals angle D. What's the reason? Exterior angle of cyclic quad. What's your remaining angle? Angle C equals angle F, remaining angle. Therefore, triangle ABC is similar to triangle EDF. Done. Now remember, in one question, obviously the last question you have to use, although it's 6 marks. Why is it 6? It means use the previous answers to help us to get the last answer. Always. We're using answers from previous questions in the question to answer the last one. Yusuf Abu, you still online? You still there? Ahmad Mohammed, you still in? Mango Fish, you still in? Come onliners. Nabila, you still in? Humaira, you still here? Or they're taking a Sunday afternoon nap? Beauty sleep. Right, let's go. Let's do the last one. Interesting stuff. The last one is the cracker here. The kicker is the last one. Now, obviously, we have to use the previous one's answer also. So, we know ABC is similar to EDF. So, we got a DF in a problem. We got an ED in a problem. We got a BC in a problem. So we know, therefore, AB in the previous one, AB over ED, AB over ED is equal to BC over DF. So if I put it in terms of AB on its own, because there's no AB here, AB equals ED, because I times this side by ED, I times that side by ED, ED times BC over DF. So now we start smiling. Why do we start smiling? Because we got ED, BC, DF. We got ED, BC, DF. My problem is I need to get rid of an AB. There's no AB here. Now, remember, I'm teaching you how to think. So it's not about just doing the problem. What to look for now? So the question I'm asking in my head, I have never done this question before. I just got it here in front of me. No memo. I'm doing it with you, like we are all writing this paper together. So the question I'm asking myself in my head is, how do I make that AB Fusek? The only way I can make AB go away is if, and I need to introduce that. That means here's a whole new similarity. And I need to put it in terms of AB. Because if I got AB equal to this, if I got AB equal to that, and I got AB also equal to that, game over. AB and AB can cancel, and Bob's your uncle. Then I know that is equal to that. Agreed? So now the game on now. I don't know how to do it. I haven't done it before. But now I'm going to look for, how can I get rid of A? How can I make AB? So I need a BE. So let's go look. Now we are on a witch hunt. So now we need BE. So we need BE. Okay. We need a AH. We need a AH. I need a GH. I need a G. Okay. I'm seeing it. I've got 3 lines here. I've got a parallel line there. My brain is telling me proportionality in triangle AEG. Let's look at the big triangle AE. That's what my brain is telling me. Let's see if my brain is right or is my brain effed up. Which it is. Because I need a AB. I need that. I need a that. I need a that. And I need a that. Well, it's staring me. It's screaming to me. Please use proportionality. I don't think I'm right. I know I'm freaking right. So let's have fun again now. So this was similarity. Now let's go into our friend Mr. Proportionality. Because I got parallel lines. P for parallel, P for proportion. Right. So now let's say AB over BE equals AH over HG. I want AB. Remember what I told you earlier? My brain is looking for AB. So AB is equal to AH times BE over HG or GH. Equation number 1. Equation, and this is proportionality. Prop theorem. Game over. That's equation number 2. AB is equal to that and AB is also equal to that. So that and that can cancel. Game over. Therefore, BE times AH over GH is equal to ED times BC over DF. Game over. Done deal. Done deal. Luyanda, well done. You did it as well. Brilliant. Full marks. We total the whole question. Now comes the last one for 4 and 3, the one that's going to try and moor us. Onliners, we there. Yusuf Abu, you did it. You have to use the answers from previous questions to help you with the last one. Always the case. That one big question at the end, previous questions have to help you in it. Are included in that last question. We're almost at the end now, guys. Hang in there. Hang in. It's 20 past 2 already. Let's do another one. Or before we do that one, let me give you one on proportionality. Euclidean 96. Right. The next one on proportionality is very popular. We have done it in previous workshops. I'm going to leave this other big cracker one for last. The next one is a highly popular question. You need to know its style. Okay, here we go. Here we go. It's an easy one for many of you. You have done it before. But when you see double parallel lines in one question, so you can have a line going like that, you got a line going like that, you got a line going like that. I know you've seen it. Open up all your past papers, you'll see double parallel lines. Let's say this is A, F, B, C, A, F, B, C, D, E. We have done this in the previous workshop as well. This is parallel to that. That one there is parallel to that. 10, 12. 10, 12. This small piece is 6. Right, find the length of AC. Find the length of AC for 6 marks. This is an easy one. Yeah, boy, yes, we finish on the dot at 3 p.m., not a second later, because we've got buses here waiting for learners as well. Right. The minute you see a double parallel line, remember one pair of parallel lines only occur in one triangle, so you have to work with each triangle separate. Parallel line 1, parallel line 2. So let's look at the first set of parallel lines. That. Wait, let's highlight it. Let's go there, 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 and there. Right, so we want AE. So AE over ED equals AF over FB. Proportionality. So we want AE. AE over ED is 6, is equal to AF, which is 10, over FB, which is 12. AE equals 10 times 6 is 60 divided by 12. AE is 5 units. AE is 5 units. Right, so we are done with the one pair of parallel lines. Now we go in for the next set of parallel lines. So now let's go here, big triangle. Take your pencil colors with you in your exam so you can identify what you're looking for. We got that and we got that. Right, now we need DC. So obviously, DC over AD, DC over AD. We're now looking in triangle ABC. This one was in triangle ABD. This was in triangle ABD. Now in triangle ABC, DC over AD equals FB over AF. DC is what we want, over AD is 11. 6 plus 5 is 11. FB is 12 over 10. DC equals 12 times 11 divided by 10. 12 times 11 divided by 10 is 13,2. So now we get that as 13,2. The question wants AC, the entire length. Therefore, AC equals 5 plus 6 plus 13,2. This 13,2 plus 11 gives me 24,2. 24,2 units. There we go. We're done. Learn this. Learn how to separate proportionality in one triangle. Okay. Now for some fun. Here's a 7-mark question coming up. So let's turn up the heat. We're cooking. Let's go. You took it down? We're done with that. Next one looks like an easy try. I mean, it's such an easy shape. So they give you that. They give you that. So nice to see some grade 12s outside having a ball of a time. Enchanting. A D C. Right, they tell you DC equals X. DC equals half AD. In the diagram, AB is a diameter. AB is a diameter. Right, let's go. Right, question number 1. Let's see if you guys can get the prove that BD over DC equal root 2. Prove that BD over DC. BD over DC equals square root 2. Number 2, Calculate the perimeter of triangle ABC. Calculate the perimeter of triangle ABC if AD equals 10 millimeters. 4 and 3. 4 marks, 3 marks. Go, Khalid, go check what's happening with some of those learners that have decided to. I don't know what's happening. Bruh, ask them. They came to waste their time. Some learners are playing netball outside. Nice. I'll show you how maths is going to show them hoops in the exam. Right. DC equals X. DC equals half of AD. Two DC equals AD. Am I right? So AD equals that's X. 2X. Right. Quiet guys, quiet guys, quiet guys. Right, so the first thing I did, I manipulated there on the top. DC is equal to half AD. So I multiplied both sides by 2. 2 DC equals AD. DC is X. So 2X equal AD. So AD is equal to 2X. AB is a diameter. Oh, I forgot to give you one more line. There. Right, there we go. That's your diagram. Go for it. This is a final exam question. 4 marks and 3 marks. 7 marks. Come grade 12s. Do you think we're going to go in for similarity here? Yeah. Yes, I would go in for similarity. Why not? Of course. Of course there's similarity here. It's screaming at you. Your two triangles. I think I'm going to go for triangle ABC and BDC. Don't you think? So go for it. Finish it. You got it. It worked out. Did it work out? The answer is given, so you can't be not sure. You either got square root 2 or you didn't get square root 2. Let's look for another one. I'll tell you how I'm already looking at it that way, that. Call this one D1, D2. Call this one B1, B2. Why did they tell us this is a diameter? They told us this is a diameter. Obviously, that must be the center of the circle. So we know that D1 is 90. Angle D1 equals 90. Angle in a semicircle. D2 is also 90. Angles on a straight line. I'm just filling information from what's given. Adjacent supplementary. Adjacent supplementary. Right. I'm going to give you, I want you guys to answer question number 1 and question number 2. I'm taking a 5-minute oxygen break. Khalid will take over with the comments and talk to everybody. 5-minute oxygen break. We come back in and we mark. Khalid, take it away, Debra. My brains are fried.
How many of you want to know what was happening at the back? Okay, no one. I don't want to spill the beans. It's a bro code, so I can't break the bro code. So guys, you need to begin applying now for university. Don't wait for your final mark. Don't wait for your final mark in January. Start applying now because you will cry in January because they only prioritize those who had applied the previous year. So whichever university you want to go to, apply now. But it must not be CPUT. Ne? CPUT and DUT, same WhatsApp group. They are protesting every week. So you don't need that. Unless you want to do supply and chain management, including logistics, then CPUT is the best when it comes to that. If you want to do a film, you can go to AUCT. If you want to do humanities, UWC is the best, including Epicom accounting. Many of you want to do that. Then UWC is the best. You want to do ILO, maybe UNISA. The benefits of UNISA is that you are going to study online. So you can ask your husband to do the course for you. But guys, do not pay a blind eye to colleges. You can go to a college too. It must not always be a university. I promise you, some of the students that come out of a college are better than those that came out of a university. Because university, you come out with the theory, but a college, you come out with indoli, a skill. So you really need a skill over a theory. But if you want to speak good English with a nice accent, then you can go to university. If you want to say basically, actually, allegedly,
Onliners, are we back? Are we back? Are we back? Are you still there? Are you guys done? Are you guys done? We are done. We are now finishing up. What's going on here? Let's just get this thing properly in. There we go. Here we go. Here we go. Right. Let's go. Let's wrap up. We got in. Okay, I'm going to move over here to the side. Let's go here, right to the side. In triangle, because we got these. So I'm looking at ABD and triangle BDC. Right, number one. ABD, BDC. So we got angle D1 equals D2 equals 90 degrees. Right. Give me another angle that's equal in these two triangles here. Right. From the main diagram, that angle there is equal to that angle there. Right? So tan chord. So angle A is equal to angle B1. Tan chord. The last one is the remaining angle, which is angle B2. Let's make it a full circle, is equal to angle C. Angle B2 is equal to angle C, remaining angle. I'm writing slow because I'm thinking as I'm doing it. Therefore, triangle ABD is similar to triangle ABD. ABD. Shh, shh, shh. Guys, I need silence there. Thank you. Right. The open circle to the closed circle to the 90. The open circle to the full circle to the 90. BCD. BCD. Right? ABD, it was the open circle to the dot to the 90 degree. So you must have open circle to the dot to the 90 degree. This is the way I do it. So I use different shapes in there just to identify which angles are equal to which angle. So it helps me to determine my similarity. Right. Therefore, okay, so we did that. We want BD over DC. BD over BC. So aren't we going to go A? So we got the AD and we got a DC. So BD over CD, BD over CD is equal to AD over BD. From here, cross multiply, therefore BD squared is equal to AD times CD. BD squared is equal to, what's AD? 2x. What's CD? X. Therefore, BD squared is equal to 2x squared. Therefore, BD is equal to the square root of 2x squared. Therefore, BD on its own is equal to, x squared is a perfect square, so it's x root 2. Or you can say root 2x. BC over CD, BC. We got BD over CD equals AD over BD. That we got right. That's correct. So BD over CD, BD. Right, so let's go now. We're done with this. We need BD over DC. We need BD. We got BD. So let's go. BD over CD or DC is equal to root 2x No, what's BD? BD, yeah, BD over DC. DC is x, which is equal to x, and x will cancel out, which is equal to root 2. There we go, done. Let's do the last one. The perimeter of triangle ABC, if AD, where's AD, is 10 millimeters. AD is 10. And therefore DC is half of 10, which is 5. They want the perimeter of triangle ABC. So A, B, C. They want the perimeter of this. Mm. It's only 3 marks, but there's some serious calculation in the last one, guys. So we got BD over DC is equal to root 2 from the previous one. The last one we're doing before we wrap up. Right, let's go again. Let's go again. So they want the perimeter of ABC. So we got that. We got that side. We need this side here. We need that side there. But we also got BD over DC equal root 2. We got BD over DC from the previous one is equal to root 2. So we know that BD is equal to root 2 DC. So BD is equal to root 2. We got DC. DC is 5. So BD is equal to 5 root 2. BD is 5 root 2. Interesting. Shit's going down. Now, why did I get this? Because once I get this, I can get BC. So now I'm going in this triangle here. I'm now saying BC squared is equal to 5 root 2 squared plus 5 squared. So BC squared is equal to 5 squared is 25 times 2 plus 25. BC squared equals 50 plus 25. BC equals square root of 75. So BC now we just found is square root 75. I got this whole length to be 15. I got this to be root 75. I now need that side there because they want the perimeter of ABC. Side plus side plus side. So now 15 squared. 15 squared in the big triangle. I'm looking in triangle ABC. 15 squared is equal to root 75 squared plus AB squared. Pythagoras. 225 is equal to 75 plus AB squared. AB squared equals 225 minus 75 is 150. AB is equal to square root 150. Now I got this big side as square root 150. Now I must calculate perimeter. Only for 3 marks. All the shit for 3 marks. Well done, government. Therefore, perimeter is equal to side plus side plus side, square root 150 plus square root 75 plus 15. Moment of truth, final answer, bringing us to the end of today's square root 150 plus square root 75 plus 15. My final answer, 35,9. 35,9 millimeters. There we go. Did you all look? Onliners, did you get 35,9? I hope you did. Guys, that has brought us to the end of 2 days. I hope you guys enjoyed it. Lots of love from myself and Awqaf. I just want to thank all our onliners, all our on-siters. Thank you all for being part of this groundbreaking program. And good luck for your prelim exams. And we shall see you again before finals. From me, Mr. K, from Awqaf, good afternoon. Thank you so much. Lots of love. May the Almighty be with you. Go smash that paper. Don't be in a daze like you were now. Good luck, good luck, good luck. And we'll see you again before the end of the year. Good luck, grade 12s. Good luck, Mitchell's Plain. And goodbye, Cape Town. Thanks, Khalid. Thank you to our tech team, Samit and Nazmi. Thanks to our co-host or our host, Khalid, who kept us going as well the entire weekend. Been an amazing weekend. Go home, go safe, be safe, and get that distinction in math. Time to go back to Joburg.